Hello, everyone, and welcome to week 5 of the 18th annual Symposium on the Conservation and Biology of Tortoises and Freshwater Turtles. Today's sessions are going to cover field studies and population demographics. And also of note, poster session 2 is live as of today, so head over to turtlesurvival.org and check that out. There's a lot of great stuff there. We're going to go ahead and jump right into it with our first presenter, Thomas. Are you ready to go?
Yes, I am.
Thank you.
Okay, good morning, afternoon, and evening, everyone. From here in Front Royal, Virginia, I'm Tom Ockery, and I am a conservation ecologist at the Smithsonian Conservation Biology Institute. And I'm talking to you today about nest site selection and nest success for the wood turtle in an unusual landscape here in Northern Virginia, where I'm excited to be talking to you on behalf of all of my co-authors. So today we're talking about the wood turtle. In particular, we're talking about the fact that the wood turtle is endangered across its range in northeastern United States and adjacent Canada. And that's primarily because of habitat loss, habitat fragmentation, poaching for the pet trade, and mortality on roads and mortality as a result of agriculture. And as a result, we've seen range contractions across its entire range as the species has seen habitat fragment across the Northeast and across the Great Lakes. So as habitats have converted from forest to agriculture, and then ultimately in Virginia and the Mid-Atlantic, for example, to exurban developments and suburbia, we've seen declines in habitat quality, fragmentation, and overall loss of habitat across Virginia and in the Mid-Atlantic. And the result in the last 30 years in Virginia is that we have seen inside this polygon of the former distribution of wood turtles a severe range contraction, such that we've lost most of the viable populations east of the Blue Ridge in Virginia. We're in the process of losing many of them in the Valley of Virginia. And really, we only retain populations in the Ridge and Valley against the western border of Virginia with West Virginia. And so with the prospect of development in that region, in particular in the northwestern part of Virginia, we think that the US Forest Service lands, that is the National Forest, may be one of the only places where the wood turtle will remain in perpetuity. So the problem with that is that Forest Service lands in Virginia are upland. They're mostly closed canopy with very small streams with low flows and fairly high gradient. And that's in stark contrast to what is most of the habitat for the wood turtle across its formerly glaciated range in the Northeast and in Canada. That is wide, shallow streams that are approximately 10 to 12 meters across and have higher energy and more mosaic of habitats. And in fact, they have large stream nesting banks like this one shown here. And that is in contrast to what we see in the forest lands in Virginia. These road cut banks and other anthropogenic sites where we think and now know that wood turtles nest. But that is the limitation of where they can nest in these upland forested sites. So the result is that the purpose and aims of our study was that the range contraction of the wood turtle could potentially limit populations to US Forest Service lands in Virginia. So therefore, there was an urgent need to understand demography, reproduction, movement, connectivity, and viability. In particular, the US Forest Service staff knew that wood turtles nested on these road cut banks and they wanted to bring in sand as a subsidy. So DGIF, that is the State Wildlife Commission, commissioned a study to understand nesting at this US Forest Service site. And we at SCBI wanted to understand the reproductive ecology of the wood turtle at this site. So effective population size, nest site selection, and reproductive success, among many other things. So in 2010 to 2015, we undertook a study with field methods where across the spring and the fall, but particularly in the nesting season from mid-May to late June, we undertook adaptive sampling of the stream, the forest, and the field and then forest and logging roads and trails. We radio telemetered turtles that we found that were gravid, and we also attached thread spools that were half a mile long to many of those turtles in order to find their nests. This led to kind of an iterative process where turtles showed us where there were more nest sites that we learned about across the season and across the years. So we iterated this process across years in order to get a comprehensive understanding of where turtles were nesting at this site. When we found nests, we identified the female that nested there. Then we protected the nests. Then we excavated the clutch and eggs in order to evaluate them. And then we reburied them with an eye button. And then we evaluated the habitat for soil and vegetative characteristics at the multi-meter scale. We also worked in a series of controls across the site, where we first obviously took those variables at the nest site. Then secondly, we took those variables at a randomly selected site inside the forest matrix within 300 meters of the site. And then we also did the same at unused banks across the site. And then ultimately we took those same variables at unused sites within a used nest bank. In that way, we had several controls that we can compare nest sites to for those variables. In the last couple years of the study, 2013, 14, and 15, we also put cameras on unprotected nests, nests that we did not disturb in order to avoid leading predators to. And we also put cameras on the forest road and the forest itself around the study site. And then in 2015, we used 20 cameras to monitor 16 well-known unprotected nest banks, and we surveilled the site by driving the forest road nearly every day for predation of nests. So our analysis were population estimates using log linear Jolly-Sieber and Cormack Jolly-Sieber estimates for abundance for open models, nest site selection using 6 environmental variables using box and whisker plots and Kruskal-Wallis and Dunn's tests, nest site selection using 5 environmental variables using generalized linear mixed models with environmental variables as the fixed effects and nest patch identification as the random effect. We also looked at distance from winter hibernacula to a selected nest patch versus the closest nest patch using Mann-Whitney U-tests. We also looked at the probability of revisitation. In other words, female fidelity and patch attraction, where the probability equals R over N prime, where R is the number of observed revisits and N is the number of possible revisits, with derivations for females and focal patch. Then we looked at survival to emergence. That is the proportion of viable eggs that survived to emerge. And in that case, we used 3 models with female and clutch variables, climate variables, and habitat variables, and then a global model with significant fixed effects and female identification as the random effect. Lastly, we looked at nest predation annual variation. So the first important result is that we effectively censused this population. If we look at the females that were captured during the nesting season, we see that we captured between 49 and 57 turtles during the nesting season, and then we captured between 49 and 58 turtles across the year. In actuality, we captured 66 total individual females and 65 during the nesting season among 263 captures and 241 actual nests. And our abundance estimates are almost exactly the same as our capture numbers and our total captured number of individuals. For nest patch selection, we see that females selected almost all anthropogenic sites. 1% of nests were on the gravel road. Only 4% of nests were on the actual stream bank. 5% of nests were in open areas called cutting units where they had logged. 8% were on forest trails for recreation. Power line cut represented 12%, and borrow pit, an old pit that was used to maintain the road, represented 14%. The vast majority were on those road cut banks, 56%. If we look at the variables that were influential to nest site selection, we see that canopy cover to the south was significantly lower at the nests than it was for the other treatments, either within the patch, among other patches, or within the forest matrix. We see that open ground cover was significantly higher compared to the other treatments. Again, within, among the patches and among the forest treatments. We see that percent gravel substrate was significantly higher than the other features, and we see that distance to road was only different for the forest matrix and slope was only different for the forest matrix. We also saw that dominant aspect was not different among all of the treatments until we actually looked at 30 randomly sampled sites around the entire area in order to demonstrate to ourselves that in fact the limitation of our sampling within 300 meters of the nest site more or less had us always on the same slope. So dominant aspect does vary across the site. Now, if we look at patch type selection models, that is comparing the patches to the forest matrix, we see that canopy cover to the south, the amount of open ground cover and gravel were the important drivers, and those are fairly steep slopes for those variables. If we look at patch features, that is unused banks versus used banks, we see the same variables plus slope. And in this case, the variables were not as steep in their slopes, suggesting not as dramatic differences between unused and used banks. And then finally, if we look at where they selected nests on those patches, we see that the same variables were involved: open to the south, canopy cover to the south, open ground cover, gravel and slope. But again, the slopes were not very steep, suggesting not much difference within the patches. We also looked at the distance that turtles moved. And turtles, in fact, moved quite long distances to their preferred patches, somewhere between 1 and 2 kilometers on average, but up to 8 kilometers, and even in one case, up to nearly 14 kilometers. And we did see a significant difference between the selected nest patch and the closest nest patch for our sample, suggesting that turtles were moving disproportionately to their nest patches that they actually showed real fidelity to. We actually see that for females, nearly or greater than 50% actually return to sites on average greater than 90% of the time. Whereas with nest patches, we see about even numbers of females that chose patches once versus females that chose patches greater than or repeatedly returned to patches greater than 90% of the time. If we look at nest and egg survival to emergence, for our protected nests, naive overall survival was very high. In other words, we had very high survival of native nests that were protected. If we look at egg survival from the raw data, we see that survival of eggs to emergence was actually quite high too, 61%, and our modeled egg survival was 64%. If we look at the factors that influenced egg survival to emergence, that is hatchlings' ability to leave the nest, we saw that the mean precipitation, the mean temperature, the percent of gravel, and the clutch mass to some degree were important influential variables in that. And we're continuing to evaluate that as well. Now, lastly, if we look at nest predation in the last 3 years of the study, we see that only 11%, that is 6 of 55 nests that were left unprotected, were actually predated while we were there in 2013 and 2014. And that's dramatically different from the effect that we saw in 2015 when we were not there all day, every day. And so in 2015, we saw that 20 of approximately 55 nests, and remember, we censused the female population there, were actually depredated, and 55% of that was from striped skunks. That is 11 of the total 20. So finally, our conclusions are that factors that influence nest site selection are not different from the literature, but they're fairly unique to sites in this US Forest Service land, and they are same types of features from the literature, but they're anthropogenically maintained at this site. So there aren't any natural features where turtles can nest at this site. Turtles travel long distances between 1 and 8 kilometers to generally preferred nest patches that generally show high fidelity to. Greater than 50% had a return rate of greater than 90%. Some females chose patches only once, so there was some polarity there or some hedging there, but also at a rate similar to those who returned to selected patches greater than 90% of the time. Innate survival of the protected nests was very high, almost 90%, but predation remains to be directly tested. Egg survival to emergence was also very high, somewhere around 60%, with the factors that influence hatching and emergence driven primarily by climate, with some influence of habitat and clutch mass. In our study, female attributes, in this case BMI, did not seem to be important. And then lastly, predation of unprotected nests during the primary years was very low, 11%, but nearly tripled in our absence, with striped skunks accounting for 55% of the depredation events. And with that, I'd like to say, excuse me, thank you all to all the folks that helped with this study along the years and have helped with all of the analysis. And if you are interested, please help support the Turtle Survival Alliance.
Tom, we have 3 questions here. You see those?
I'm opening them up now, yep. Okay, yeah. Any idea where the hatchlings go after emergence, right? So yes, we actually do know where the hatchlings go after emergence. One of our folks undertook a study to track hatchlings down to the stream, and there's often quite a long distance to the stream, but we found that survival on the way down to the stream was not heavily impacted. So in other words, they did not die on the way to the stream, but mortality events were often focused around the stream. Trying to get my chat back up. Okay, number 2, how many clutches do wood turtles lay per year? In this case, in Virginia, we only know of 1 clutch per year. So in all cases, in this study, we only know of females becoming gravid once per year. And then number 4, how is the U.S. Forest Service using this information in management decisions, right? A very important question. So we're constantly in the process of working with the Forest Service to help them manage these sites. We're trying to present more of that information as well, but they've closed the road to recreation during the nesting season. We want to get them to close the road at other times of the year. I also see that question number 1 is, how can we stop other people from taking turtles and eggs, or how can we prevent them from being predated? Well, we certainly can protect them, but that's a lot of work. And then question number 5 is, what about substrate compaction? You mentioned a few sites actually on roads and trails. What was the survivorship success of those? Right, good point. So the survivorship of some of those sites with compaction was generally low compared to other sites. So it was variable across sites. But yes, some of those sites where there was substrate compaction or thick substrate was very low. Thank you.
Hi, I hope everyone can see and hear me.
Everything's perfect.
Okay, great. So thanks, David. So good evening, everyone, and hello from Mumbai. My name is Rishika from TSA's India program, and today I'm going to be talking on behalf of my co-authors on a project studying the freshwater turtle communities in the lower Sarju River in northern India. So before I begin, I'd like to heartfully thank the Delta Foundation, the Uttar Pradesh Forest Department, the TSA Turtle Survival Alliance, and the Wildlife Conservation Society for all the support that has made this project possible. I'd also like to thank the Symposium for giving me this opportunity to speak to you guys today. So I'd like to start off, just give a little bit of a background of turtle conservation in India at the moment. So even though India has 35 species of turtles, 29 freshwater and 5 marine species, nearly 75% of freshwater species are threatened at the moment. India ranks third in terms of countries with the highest number of threatened freshwater species. And yet turtles are generally a neglected taxa amongst conservation circles, with more attention generally given to megafauna like tigers, rhinos, and elephants. Even amongst turtles themselves, marine species tend to get a bit more attention, while any freshwater conservation gets couched within other herpetological programs as a subsidiary process. And because of this lack of basic knowledge on turtle biology on Indian species, it creates barriers in designing and proposing conservation programs. So it's really difficult to sell a plan to save a species to someone if we have no idea what their status is in the wild or their specific ecological or husbandry needs. But at the moment, there has been a recent rise in exclusive freshwater turtle programs in the country, especially, and one of the biggest supports come from a national program called the Namami Gange program, launched by the Indian government, which has clear objectives related to turtle conservation and breeding programs. So the project itself was born from the simple lack of fundamental knowledge about turtles in India that would be needed to save a species. The Lord Sarju site itself was incidentally discovered by chance in 2007, and eventually in 2014, a baseline study was set up for the primary species, which was the crown river turtle, Hardella thurgi. Although over time, as the river's species richness was discovered, the focus was shifted to study the entire assemblage itself. So regular sampling started around 2017, which is still continuing till date, and it helped us to establish that this one site holds probably one of the largest populations of Hardella thurgi in the state, if not the country. And at the moment, it's probably one of the longest baseline study projects in India. So the lower Sarju River itself is part of the Ghagra Sarju River system within the Gangetic Basin in northern India. So it's a roughly 200-kilometer river that's little ribbons across the center of the map around there, and eventually joins the main stem, which is the Ghagra River towards the left. And it's located within the Tarai Arc landscape, which is an area of consisting of a mosaic of fragmented forests, grasslands, swamps, and wetlands along the Indo-Nepal border, which has also been recognized by the TSA as one of the top 5 turtle priority areas in the country at the National Tortoise and Freshwater Turtle Conservation Action Plan workshop in 2017. So the Lower Sarju River itself has a variety of habitats, so it's ranging from heavily vegetated sections with shallow depths to running to more open and deeper waters interspersed with much deeper pools within it. This is home to 9 species, making it one of the most biodiverse rivers in northern India and representing nearly 1/3 of freshwater species in all of India. And most importantly, this entire 200-kilometer stretch is completely unprotected. So out of the 9 species, you got 4 soft shells. You got Chitra indica at the top left, Lismus punctata, and the 2 Nilsonia species, Hurum on the left and Gangetica on the right. And out of the 5 hard shells, you've got Geoclamis hamiltoni on the top left there, which has recently been uplisted to an endangered status according to the IUCN Red List. And the Hardella thurgi there in the center has been proposed to be endangered as well. So our project site itself is actually located in a really, in an area which has really high human activity, with a bridge running right over the area where we set our nets for sampling, which is regularly used and is surrounded by fishing villages that regularly fish in this area. It's also an important religious site with 2 temples on either banks of the river on either ends of the bridge, so just around that bush there and just around this bush on the right as well. And is regularly visited by heavy crowds on important festival days. So the methodology we've adopted over a 9-month field season, which we split over pre-monsoon and post-monsoon, which runs from July and August. So we tend to go for 12-hour sampling sessions, setting our nets for 12 hours, and we aim for a minimum of 5 sessions per month. And we tend to set gill nets of different sizes. So that's one of our field assistants there, setting our gill nets in a different section of the river. And we try and spread out the sessions so we get a whole 24-hour reading of that particular site. And we tend to check our nets every 2 hours to make sure any animals don't drown. So once we've got our animals, we generally tend to collect basic morphometric information like carapace length, plastron length, width, mass, sex, species, and we try and do that as quickly as possible and return them to the river as soon as possible. So over the duration of this project, anecdotally, there have been quite a few interesting observations. The first of which that pops out is this Chitra indica individual, so a juvenile here. And we've only found this one individual over 3 years. So it begs the question where the rest of them, although we do know that there is a larger individual somewhere at the back because we've seen it from the top of the bridge at the back there. Again, one of my other favorites, Morenia petersi, Indian eye turtle. So the species tends to prefer more heavily vegetated areas with slightly shallower waters, but we've encountered only 3 individuals over 3 years, but in this site, which does not match that habitat profile at all. It has a deep pool. So it'd be interesting to know if there's any more or how we found it. Tend to see morphological variants as well, where, so this is a Nilsonia hurum individual, a female, and generally they're more olive green in color with a very clear mottled pattern across their carapace and face. But here is this individual is highly pigmented, so it's nearly black and you can barely tell the mottled pattern on the face as well. We tend to see seasonal sex ratio differences as well. So this is the crown river turtle, got a female on the left there, larger one, and a male on the right, displaying courtship behavior. And we tend to encounter males pre-monsoon coinciding with the courtship season, but post-monsoon, they completely disappear. So it begs the question, where do they actually go? So far until 2019, we've spent 73 days, totaling a total of 845 hours. And till date, not till date, till the end of 2019, we captured 2,004 animals, out of which 1,748 were unique captures with 256 recaptures. Out of that, all 9 species were recorded, and looking at the abundance trends, Hardella thurgi seems to be disproportionately high compared to the others at nearly over 1,600 individuals. But if we remove that information, if you look at the graph below, we tend to see a few more other trends. So there's the other abundant species are the 2 Punctura species, so Puncturia tentoria flaviventer and Punctura tecta, as well as Nilsonia hurum and Geoclemis hamiltoni. So at the moment, we still believe we definitely need a lot more data to get any definitive trends on the species here. But on a preliminary level, we still see a few trends pop up. So there's fairly high survivorship amongst all the species with stable or slightly increasing populations. Because we caught so many Hardella, we've been able to look at the sexes differently and see that there's actually a higher survivorship amongst females compared to males. However, Nilsonia hurum seems to have the lowest survivorship, and this probably coincides with the fact that they're heavily predated upon because for local illegal meat markets. So if we split that over seasons to see if there's any difference between pre and post monsoon, again, Hardella is pretty standard, doesn't seem to show much of a trend, but once we remove that and look at the graph below, the 2 Punctura species clearly show that they're encountered more often pre-monsoon, while Nilsonia hurum and Geoclemis hamiltoni are encountered more often post-monsoon. If we split that further per year, again, there's not much of a trend with Hardella at the moment, but if we remove that, we expect to see a zigzag pattern, which we do with Geoclemis hamiltoni at the bottom there, which is the red maroon bars. So they're higher in post-monsoon, matching the previous data. And an inverted pattern, same with the Punctura at the back there with the light blue. So again, captures adjusted for the hours spent sampling tends to corroborate the same data where you've got not much of a trend seasonally with Hardella, but if you look at down below, you've got the two punctular species have a much higher encounter rate at in the pre-monsoon season, running from Feb to June, especially in 2019. Interestingly, Nilsonia hurum seems to be encountered across all seasons, and we possibly sort of suspect it might be closely related to Hardella in terms of ecological, like the habitat needs, or probably an indicator species of some kind. So looking at recapture trends, a total of 256 recaptures there's pretty standard rate in the first 2 years, but by 2019, they drastically increased to peaking up to 30%. So as we aim to continue this as a long-term project for several more years, we're constantly refining our methodology to collect more salient information that would be helpful. So one of those has been expanding the project to multiple sites. So currently, in addition to this current site, we have 2 other sites that we sample at. And we also have another 6 that have been sort of shortlisted out of a previous survey. We'd also like to sort of look at, rather than the main river, look at oxbow lakes and backwaters as well. And one of the biggest things we want to change and are planning to is reducing sampling gear bias by using more nets, different kinds of net, hook nets, and maybe baited traps and things like that. So as is the case with any natural history or population study, the aim is to eventually use that information to address conservation issues, which are continuously on the rise. As I mentioned earlier, there's severe human pressure at this site because of its holy status. So this is a picture taken from one of the festival days where people come in their hundreds, if not thousands, to sort of pray and bathe and throw sort of offerings into the river, end up heavily polluting the site as well. And because the entire river is a holy river, this kind of scene is common across its entire 200-kilometer length. Incidentally, the 5 gentlemen in the center there are part of a local NGO that works closely with the TSA India program to promote awareness about river pollution and turtle conservation in the area. So we're very thankful to their efforts. Another issue here is the fact that this entire river is unprotected. So fishing and poaching is very prevalent, but there's little we can do to take any action against that. But that's where information from projects such as these help us, where this baseline data that we've been getting, we've been using it to make recommendations to get this area registered as a community conservation reserve. One of the most pressing issues at the moment is the fact that there's a proposed expansion of this bridge at the back here, shown in one of the earlier pictures. And again, the information we've managed to collect over the last 3 years has been proving vital in making recommendations to authorities to shift the construction or even prevent it completely. So what's most interesting to me about this project here and at this single site is the fact not the answers given, even though the answers it's giving, but also the scale of research questions emerging from this one single site. And the possibilities are endless because you can multiply those research questions 9-fold based on the species richness here. So I really think this is one site that has the potential to revolutionize freshwater turtle research and conservation in India at the moment as this project continues in the future. So thank you very much for giving me this opportunity to speak today. And I think I already have a question. So why not use trammel nets instead of gill nets? You said many different gill nets at different sizes. So it's more, I mean, that's definitely something we can consider, and we look into usability of trammel nets. We're also sort of limited to what is available. So generally we adopted using gill nets because we use local, we try to give sort of employment opportunities to the local fishing villages and sort of try and educate them at the same time. So our field assistant is comfortable with using gill nets. So that's what we started. But again, like I mentioned, we definitely want to keep revamping our methodology and upgrading it. So that's definitely a suggestion we'll take on. Thank you very much, wherever that came from. So it's higher. So what do you mean by higher survivorship of females over males? So it's just, it's very preliminary sort of information and sort of analyses that we've done. to sort of get that, and it's shown like it's just the figure at the top that's shown like a higher survivorship. So I think again, I think that's probably a consequence of the fact that we tend to catch more females throughout all the seasons compared to we only catch males after monsoon, before monsoon. So there might be a difference. We might need to see more males to actually see whether that trend, but at the moment the analysis shows that there's higher survivorship in females. Are all these species known to be riverine, or is it marginal habitat for some? It varies. Again, there's such little information known about Indian turtles that we still sort of answering this question. So we know something like Hardella thurgi is definitely very, very aquatic. So I don't think they don't even come onto the bank to bask. They're fully aquatic, so all their, and possibly their nesting happens in the water as well. But there are other species that tend to come out of the water for basking and nesting. So again, there's just such a lack of information that these are brilliant questions that we could definitely research in the future. Thank you very much, everyone. I'll hand it over back to David.
All right, up next we have Donald McKnight, who is in Belize at the moment, and it looks like they all got to dodge a hurricane overnight. So let's hear some more about Hecate. Thanks, Donald.
Okay, hopefully this is working. Good morning, everyone, and thank you for tuning in. I'm really excited to tell you about the work that we've been doing here in Belize on the Central American river turtle, which is known locally as the Hecate, and that's probably what I'm going to refer it to as throughout the talk. Before I start talking about what we have actually done and found, though, I want to go ahead and give everyone just kind of a brief overview of how this project came together and who all's been involved with it, because it's a pretty extensive project. There's a lot of people involved, and it came together almost overnight. And so I want to just give you a little bit of that backstory. So in December 2018, the Belize government generously agreed to fund some intensive Hecate work starting in 2019, which was obviously excellent news. But the catch was that Hecate field season is really about March to May, which meant that we had just a handful of months to go from finding out that a project might be possible to actually implementing a full project. And fortunately, a lot of people stepped up to make sure that that happened. Jacob Marlin and Heather Barrett at Be Free, as well as multiple people at TSA and Bart Harmson, who works for PACT, all really led the initial efforts to make sure that we actually secured the funding and got the logistics work out, got permits and supplies and everything that we would need for research. The Missouri State University Turtle Ecology Lab, led by Day Ligon and Denise Thompson, agreed to actually design the research and carry out the fieldwork. And they invited me to help out with that, as well as Ethan Hollander and Hunter Howell. And the Delta Foundation chipped in with additional funding, and Missouri State University as well was really helpful in getting the logistics of this worked out in a really short time period. And thanks to everyone's efforts, we actually pulled it off and managed to be in the field by April last year. And really importantly for these efforts, once we were in the field, we had fantastic help from our Belizean partners. Tom Pop and Jaron Serrano, who work for Be Free, went out with us every single day of field work and were absolutely essential to this project. Yamira Novello, who works for WCS as well, went out with us on multiple occasions and was really helpful. And also we made some really great partnerships with some local conservationists at one of our study sites. One of our sites is actually partially on a wildlife refuge that's managed by the local community. And the community leaders there, particularly Mr. Albert Gill and Miss Colleen Joseph, were just fantastic to work with, very interested in conservation, very happy to help with Hecate work. And so we really look forward to continuing to build that collaboration in the future. Now, this is very far from everyone who was involved with this project. There were a lot of other people working behind the scenes. So again, I just really want to say a huge thank you to everyone who was involved with this and actually made this research possible. And so with that, let's talk about Hecate. Hecate are very large, strictly aquatic, strictly herbivorous, highly specialized animals They're absolutely stunning and have quickly become just one of my favorite turtles in the world, which is saying something. This species was once really common throughout Belize and parts of Guatemala and Mexico. Unfortunately, though, its populations have declined drastically, and currently it's listed as critically endangered. And the reason for that is really overharvesting for human consumption. There's a very long history of people eating hickory. They're associated with a lot of traditions and festivals and celebrations. But unfortunately, the current rate of harvest is very unsustainable and has led to pretty large population declines. Here in Belize, the first alarm bells about population declines were really sounded back in the 80s when Don Mall did some countrywide survey work. They were then echoed again in the 90s with John Polisar's work. And then in 2010, Rainwater and others did another follow-up countrywide survey and found that there were much lower numbers of hickory that they were catching than what Mall caught several decades earlier. And also there were a lot of sites where they simply failed to catch hickory. And so obviously, based on that, there's really need for a lot more work to be done on this species. And especially there's a need for some really fine scale work to understand more about population sizes and demographics. And so that's what we tried to accomplish with our work last year. We were working at 3 sites. The first of them is what I'm going to call our closed creek site, which is up here. These blue points are where we were running trammel nets, and you can see a picture of the site down here. It is a creek, but during the dry season, when we were working, it's a closed system, because what you have is this series of really large, deep pools that the hickory really like that we were trapping in. But then on either side of it, the creek becomes very, very shallow and has these little riffles that the hickory don't really move through. So during the dry season, the area we were working is closed. During the rainy season, there's no such thing as a closed system in Belize, everything next to us. This site is really important because it's one of the few sites that still seems to have historic numbers of hickory. There's very little harvesting at this site. It's on private property and it's pretty remote. There's actually a guard station right there. So there's very little hickory harvesting, and it seems like this site has more or less natural hickory densities. In contrast, the other sites we were working at do have harvesting. We don't think that it's quite as much harvesting as a lot of the other sites in Belize, but for sure there is some harvesting that takes place. And this year, actually, we know of multiple poaching events that have happened there, unfortunately. Those 2 sites are first this one that you see pictured here, which is our closed lagoon. It's about 3 kilometers long, and on either side, it dries up during the dry season. And so again, during the dry season, it's a closed system. And then finally, we had this open creek system, which is an open system year round. And so we ran trammel nets in April and May. It's been a lot of long days and long nights out there catching turtles. But fortunately, we had a lot of success at these efforts. We caught a total of 193 hickory. 115 of those came from our closed creek site, 44 from the closed lagoon, and another 34 from the open creek. And once we start looking at captures per effort, the differences between these sites really start to become obvious. So at our closed site, our closed creek site, where there's very little harvesting, we caught 1.12 hickory per hour that we ran a trammel net. In contrast, at our closed lagoon site, we only had 0.17 hickory per hour. And at the open creek site, we only had 0.13 hickory per hour. So very clearly, much higher capture rates at the site that has very little harvesting than at the sites that do have harvesting. But there's a lot more going on here than just the total numbers of hickory in the system. There's also really important differences in the demographics of these populations. So what you're seeing here is just a stacked bar plot showing the percent of individuals at each site that were males, females, and juveniles. And what you can hopefully see pretty clearly here is that at our site with little harvesting pressure, the population is really shifted towards adult turtles, whereas at the sites that have harvesting pressure, it's really shifted towards juvenile turtles. To look at that a little more closely, these figures over here are just showing you the carapace lengths for the turtles we captured, and also the masses for the turtles we captured. And this red line here shows the size at maturity for hickory, which is about 350 millimeters in carapace length. So they're quite large before they mature. And again, what you can see is that at the closed creek site with little harvesting pressure, the population is very heavily shifted towards adult turtles with lots of large individuals. Whereas at the sites that do have harvesting, it's shifted towards juveniles. And we simply don't catch a lot of the really big adult turtles that we catch at the other sites. This is clearly really troubling for the conservation of these populations, because not only are there fewer hicatee than there should be, but there's very few reproductive adults, and there's few juveniles that are actually being allowed to mature and recruit into the next generation. And this really puts these populations on a very dangerous spiral towards extirpation, because it seems like there's very little recruitment between adults getting eaten and juveniles getting eaten before they make it to even become adults. So there's clearly a really pressing need for some pretty urgent and immediate conservation actions for this species to try to prevent these populations from declining any further and allow them to actually start recovering. And these declines and hopefully future recoveries in hicatee may have really important impacts on the ecosystems in general, because hicatee are really specialized herbivores. Hopefully you can see in this picture, their beaks are very serrated, and they actually have several different rows of serrations for ripping through vegetation. And in areas where we have good hicatee densities, you often see sites like this along the edges where they've been grazing on the plants that are hanging into the water. And at the densities that these turtles were at historically, they're probably really important in the ecosystem, in both cycling nutrients through the system and also in removing decomposing plant matter from the waterways. And to give you a sense for how important this would have been and how dense hicatee were without consumption, I want to look more closely at our closed creek site that has little harvesting. We were able to generate a population estimate for it. We're estimating currently about 171 hicatee. That's a fairly crude estimate. We're working right now to collect more data to refine it, but it's probably fairly close to accurate. And that corresponds to a really high density of hicatee, and importantly, a really high biomass for the turtles at the site. And before I show you what biomass we have for our turtles, I want to put this into context for aquatic turtles more generally. In a recent literature review of biomass in turtles found that the highest reported biomass for an aquatic turtle in a normal system, excluding things like a drying pool where Chinosternids get concentrated, the highest normal biomass was 877 kilograms per hectare, which was for a Trachome scripta population. Now, for our turtles at this unharvested site, based just on the turtles that we actually captured and weighed, we know that there's at least 520 kilograms per hectare of hicatee swimming around at this site, which is already very far out there on the high end for turtle biomasses. But that's just based on the turtles we actually captured. If we take the average size of those turtles and apply it to our population estimate, what we find is an estimate of 1,154 kilograms per hectare, which would be by far the highest documented biomass for a freshwater turtle. And obviously that's an estimate. It may be lower than that. It may be a little higher than that. But if you look at our confidence intervals, it's going to be a very, very high biomass, regardless of what the final number is. And that has really potentially important ecological implications. Because again, these are very specialized turtles with an unusual role in the environment for a turtle. And at these densities and biomasses that they were at historically, they probably are really important in nutrient cycling and maintaining the health of these systems. And those ecosystem services may have been lost at the current low densities that hicatee occur at. So this is another area that we think merits a lot more work to try to really understand the role of these turtles in the ecosystem. And it's very likely that conserving hicatee would actually have far-reaching effects on these systems, and really they could be an umbrella species for the conservation of aquatic systems more generally. Finally, the last thing we wanted to really do with these data is we wanted to both apply them to the previous survey effort and use them to help guide future survey efforts. And specifically what we were interested in is figuring out how much survey effort you would need to be confident that a lack of hicatee in the survey is a true lack of hicatee in the system. And to do this, what we did is we took our data, our net data from the two systems where there is harvesting pressure, and we programmed a Monte Carlo simulation to iterate over those data and look at the probability of a false negative at different levels of survey effort. You can ask me later about the simulation if you want. I'm happy to tell you the details. For now, I'm not going to go into it. But what we found is that even at a site that has the sorts of densities we were working with at our harvested sites, it'll take about 25 hours to have less than a 5% chance of a false negative. So it actually takes quite a bit of effort to really be confident that Hecate aren't at a site. And if we apply that to the survey that was done in 2010, because that survey was a large countrywide survey, inevitably not much time was able to be invested in any one site. And so what you're seeing down here is these lines are the probabilities based on our simulation. And then these points are the amount of survey effort for the sites in the 2010 survey that failed to find Hecate. And what we found is that for 6 of those sites, there would be greater than a 50% chance of getting a false negative, even if there were Hecate there at the density that we were seeing at our sites. And at 8 of those sites, there would be greater than a 20% chance of a false negative. Only 1 of those 12 sites, which you can see out here, actually had less than a 5% chance of getting a false negative. And so this information is really valuable for future survey efforts, because it means that to really be confident that Hecate aren't at a system, it actually takes a very large investment of time and effort to trap those systems. And also, it really would be worth revisiting some of these sites where no Hecate were documented in 2010 to find out if there truly are no Hecate there, or if they're just there at low numbers that are missed. Because again, when you're doing a countrywide survey, you inevitably can't spend much time at any one site. And so I want to now finally just give you kind of a brief glimpse at what's going on presently, because we all very quickly became really heavily invested in Hecate conservation as a long-term project. And to that end, Day and Denise have actually purchased a field station here in Belize to set up the Belize Turtle Ecology Lab to keep studying Hecate, as well as doing research on the other turtles here in Belize. This is one of our wood turtles here at the site. There's a lot to be done here. There's a lot to see and a lot of work to do. So once COVID allows, you all should consider a trip to Belize and come down here and work out of the station. We'd love to have you. The 3 of us have actually managed to strand ourselves in Belize this thanks to COVID. And so we're all here at the moment and have been trying to do what we can despite COVID restrictions, and have actually had a pretty productive field season. We've got a lot more population and demographic data, movement data, habitat data, and data on various other aspects of Hecate ecology. So you'll be hearing a lot more from us in the future. In the meantime, feel free to follow myself or Belize Turtle on Twitter to keep seeing updates about what we're up to, and also feel free to email us with questions or comments, or whatever you want to talk to us about. I will also just really quickly plug that I, in collaboration with Eric Nordberg, are currently working on a collaborative global project on turtle basking behavior. And we're really looking for as many collaborators as possible from around the world. So if that would be of interest of you, please shoot me an email and talk to me about that. Thank you again for listening, and a huge thank you to everyone who contributed to this project. And if there are any questions, I'm happy to answer those.
Yeah, Donald, there are 4 questions. They are in the chat, or I can read them out to you if you.
Yeah, my chat's not loading for some reason. So if you don't mind reading them, that would be useful. Thank you.
All right, question number 1. What is the average age that Hecate have to be to reach sexual maturity?
Good question. We don't know that for sure. The current thinking is probably at least over 10 years, probably somewhere in the 13 to 16-year-old range. But that's one of the pieces of data that we're hoping to really refine better and get a proper estimate on.
Excellent. Question 2. On a scale of 1 to 10, how painful is a bite with that serrated beak, assuming that you have been bitten at least once during your research?
I have fortunately managed to only be bitten by small ones. The big ones I imagine would be excruciatingly painful. But thus far, other than one bite through a wetsuit, which doesn't really count, I've managed to keep my hands out of their mouths.
Good deal. Third question, what mesh size trammel nets did you use, and what is the maturity length for males and females?
So as far as trammel net size, if you want to email me, I'm happy to talk more in person. I'd rather not put details of how we're catching this turtle just available on the internet, just, for the safety of the turtle's sake. As far as the last part of the question, can you please repeat that?
I think it's a little bit like question one. It's asking about what the maturity size is for females.
Right. So they start maturing at around 350 millimeters in carapace length. That's the size at which we start seeing large tails on the males and the change in head coloration.
All right. The last question is going to be, did you use any eDNA techniques to determine presence of the species?
No, we haven't presently. That is potentially something that could be done in the future. But I think, as everyone knows, there's a lot of caveats to eDNA work as well. So for right now, it's just been actual manual surveys.
Excellent. Thank you, Donald. We are very happy that you could join us today and that everything down there around Be Free is in great shape. And
thank you.
Up next, coming to us from Nepal, is Ramananda Rajbanshi. And I'm going to turn it over to him and see how it goes. While Pramananda is getting set up, I just want to remind everyone to go check out poster session 2 live today.
Hello, hopefully this is working.
Yes, we can hear you.
Your presentation. Yes, sir. Hello everyone, I'm from Nepal. This is me, Pramanand Rajbanshi. I'm very happy for this opportunity to participate in the 18th annual and the first annual virtual symposium on the conservation and biology of tortoise and freshwater turtle. Today, I'm going to present my field study research on the title Indotestudo elongata, written by Foraging and Forest Fire in Nepal. Now, starting with the introduction, the elongated tortoise, Indotestudo elongata, is one of the 2 terrestrial turtle native to Nepal. Indotestudo elongata is shown in the figure first. Similarly, photograph second, representing the Meninocalis tricarenta, which is a semi-aquatic turtle native to Nepal. In Nepal, local refers to the species Indotestudo elongata by different names, such as dark kachhui, sun kachua, and the pahel kachua. Indotestudo elongata, which is a critically endangered species, and in the case of Nepal, it is typically associated with the sal forest, that is the Soria robusta forest. In Nepal, till the date, 16 species and a subspecies of turtles are found, and still the research is going on. But the population decline of all the turtles are in the rapid way. Photograph 3 is representing exploited cell of Indotestudo elongata. Turtle exploitation in the Tarai, which is a plain region, is a common practice, as region is a suitable habitat for turtle. From the research by the Sayendra Tiwari 2004, documented overall the turtle species in Nepal are exploited for the meat and medicinal value. Due to the threats like the opportunistic collection for the different purposes, number of the Indotestudo elongata is decreasing. Therefore, this study focused individually on the Indotestudo elongata status along with its threats. In Nepal, species protection emphasis is given only within the protected areas, and thus let's explore outside the protected area system. Figure 1 is showing the protected areas of Nepal. The land turtles outside the protected areas need the special conservation due to the increasing threats from the fire, grazing, and the collection of the specimen. Therefore, this study was carried out to fulfill the existing gaps about the species Inotestudo elongata status and major threats. Now the research question, I use the following research questions. How is Inotestudo elongata distributed in Suri region? Are there any pressure to the survival of Inotestudo elongata in the region? And the objectives were, in the general objective, to determine the overall status and threats to Inotestudo elongata in the Suri region of Nepal. And I use the specific objectives were to identify the status of Inotestudo elongata in the Suri region, to identify the threats of the survival to Inotestudo elongata in the selected community forest. In methodology, first the study area. Figure 5 is representing the study area. Among it, the southern range of Nepal, encompassing the plain region, which is known as the Tarai, adjoining the Chure region, was selected as the study area. 7 community forests were selected for the study. Study was conducted from the April to August 2019, spending 75 days in the field. This study was conducted focusing the Chure, also called the Churia range. The equipments used during survey were the checklist, GPS navigation system, measuring tape, 100-meter tape, clinometer, and vernier caliper. Methodology took place in the 2 distinct phases. First was the occurrence site selection. Preliminary field visit to the possible occurrence site was conducted to selected community forest, and local ecological knowledge was used for the occurrence of the turtles. Second was the intensive field survey. Intensive field survey was conducted through the visual encounter survey (VES) method in the selected 7 community forests. Morphological features of the species were also recorded. 100 questionnaire was carried out using the convenience sampling around the community forest where the species were reported in order to assess the threats. Questionnaire was prepared in Nepali language. Photograph 4 is the questionnaire that I had done with the local people. People was grazing cattle at the time of questionnaire. Now the results. First, the status of Inotestudo elongata. Photograph 5 is the recorded Inotestudo elongata in the field. Altogether, the total 13 live and the 4 dead specimens of Inotestudo elongata were recorded from the community forest. 2 live and the 1 dead specimen were recorded from the plain region of the community forest. 11 live and the dead specimen were recorded from the Chure region community forest. From the questionnaire survey, 67% local reported the sighting of Inotestudo elongata in the selected community forest. Similarly, threats to the survival of Inotestudo elongata. Locals provided the information on exploitation of Inotestudo elongata from nearby forest. Figure 3 is showing the exploitation purposes in which maximum local people exploit for the purpose of meat, followed by medicine for the pet and for sale purposes. People responded multiple response of exploitation. For meat consumption is the 84%, for medicine purpose is 20%, for pet purpose is 15%, and for sale purpose is 2%. Among 100 respondents, 49 response reported exploitation of different turtle species. Local exploit the species during their time inside the forest to forage mushroom, fodder, and the firewood, and mostly during the Indian monsoon. Photograph 6 is showing the exploitation of Inotestudo elongata, that is fresh carapace of the Inotestudo elongata consumed by the local people. Majority of the respondents, 83%, responded that there were frequent forest fire in the region. Similarly, 94% of the respondents allow their cattle inside the forest for grazing without the supervision. Photograph 7 is showing representing the cattle grazing inside the community forest that I had clicked during survey period. Questionnaire about the conservation status of the turtle. Only 33% of the respondents were aware of the conservation status of the turtles of Nepal. The high occurrence, now the discussions. The high occurrence of the species in the Tsure region can be explained through the reduced human activities and the difficult terrain. The reduced occurrence of the species in the Tarai, which is southern plain, which was also reported by the locals, can be result of growing urbanization and the overpopulation of the area. The significant relationship between the capture and the consumption of the turtles from the forest could be led by the factor of curiosity of knowing the taste of the species and the traditional delicacy. Random cattle grazing poses the serious threats to the Indotestudus elongata, previously reported in the similar studies, such as the Geocleni radiata. Forest fires, which is the another major threat to the survival of the species, a major similar trend observed in the Sal forest of Nepal, is reported by the Michael and Rodin 1996. The threats are further aggravated by the low conservation awareness in the region about the total conservation. Lastly, the conclusion and the recommendation, higher record of the species from the Tsure can demonstrate the presence on Indotestudus elongata on the lower plains where it was abundant a decade ago. Regular monitoring inside the community forest cannot only reduce the grazing and the forest fire, threatening the habitat of already critically endangered species, but can be useful in controlling opportunistic captures. Community-based awareness and the habitat exploration for the species can be emphasized outside the protected areas, specifically in this previously unrecorded Tsure region of Nepal. These are my acknowledgements. I am thankful to my supervisor, Mr. Prakash Chandra Aryal, and the Mr. Sandesh Neupani, Golden Gate International College. I am thankful to the British Herpetological Society, BHS, for providing funding, Karen and the Isitrain, Kathmandu, for facilitating me with the field equipments. I would like to thank Division Forest Office, Bhairava Rupandei, for the cooperation. I would like to thank all the community forest user groups of the Rupandei and Palpa and the local. Finally, I'm obliged to my family and friends for the direct and the indirect support. Thank you, and queries are welcome. If you are interested, please help the TSC. Thank you.
Thank you, Pramananda. We don't have any questions yet. We're going to hang out in just a second and see if we get any from YouTube. Up next, we'll be hearing from Jackie. Oh, we do have a question.
Yes.
Is this strictly a forest species, or can it survive in agricultural areas if it's not harvested? Were you able to hear the question, Pramananda?
Again, sir, question.
Yes. Is this strictly a forest species, or can it survive in an agricultural setting if it's not harvested?
Around the community forest, there were also the agricultural lands. So during the survey, it was found near to the agricultural land also.
All right. Second question, did Indotestudus elongata not evolve in an environment with large grazers such as Gaur and Banteng? Why would modest cattle grazing be a serious threat to them?
This cattle grazing has a serious impact on the environment because it is cattle grazing losses the entire habitat for the species. Therefore, I think cattle grazing has a serious effect.
Good deal. Thank you. And I believe that is going to be our last question. Thank you for bringing us information on the turtles and tortoises in Nepal. And up next is Jackie. So I'm going to pass it off to her.
Great, thanks, David. So I am making this presentation today on behalf of my former graduate student, Gabby Zagorski. And the story today centers around Blanding's turtles, which are considered an endangered species, both at an international scale, so by the IUCN, And also where we do our research in Canada, they are also considered an endangered species. And then narrowing in even further to Ontario, the province where we do our work, the species is considered to be threatened. So they are a species at risk across jurisdictions. This is also a story about Blanding's turtle habitat. And in particular, I'm talking about central Ontario Blanding's turtle habitat, where the natural system is a mosaic of Canadian shield rock outcrops and wetlands interspersed in some forest habitat. And in the particular case study I'm talking about in central Ontario, this site is also of interest right now for development of a trap rock quarry. And so I want to give you a bit of background about how a proposal for a development would happen in Ontario. So currently the process here is that the developer, so in this case, the quarry developer would hire an environmental consultant, and the consultant would then do an environmental impact assessment. And that assessment is going to cover all aspects of the proposed development's impact. So it's going to include pollution, it's going to include hydrology considerations, but from the aspect I'm interested in telling you about today, it has to do with the wildlife species, so the species at risk that are present. And so when the consultant completes their assessment, they write a report, and that report is then submitted to the regulator, who's the one that makes the decision. And the regulator in this particular case study is the Ontario Ministry of Natural Resources, which has an aggregate branch that would make that decision. So recognized as a turtle expert in Ontario, I was contacted by several landowners in the vicinity of this proposed quarry to ask if I'd be interested in undertaking a research project to examine the Blanding's turtles that were at that site. And of course I was interested. I thought it would be a great opportunity to collect some data that would provide good evidence for decisions around the quarry development. And so I thought it also would be a really great opportunity for a collaborative approach. So I reached out to the consulting company and via them, the quarry company, and asked if they would like to partner on a research project to learn more about the Blanding's turtles in this area to help inform best management practices, best decision for the quarry. Ultimately, unfortunately, that collaborative effort didn't happen. In fact, I had even inquired about writing a grant proposal with the consulting company to work together, but in the end, they decided they didn't want to collaborate. But because the proposed project was to occur on Crown land, which is public land, I could still access the site. And so I acquired the appropriate permits and hired a graduate student, and that's Gabby, who you see here, to undertake a master's degree to learn about those turtles in the area to, again, better inform the quarry proposal. So Gabby's thesis had several different aspects. I'm just going to touch on three here that are relevant to the case study that I'm telling you about. So the first was about population ecology. So how many turtles are there at the proposed quarry site? And then there was a spatial ecology component, and this was asking about how the turtles use the land. And what's most important here is with respect to where they nest and where they hibernate, because both nest sites and hibernation sites are considered critical habitat under the endangered species legislation in Ontario and Canada. And so the final piece of that was to take the spatial ecology data and apply the legislated mapping that we have in place for Blanding's turtles. So at the provincial scale under the Endangered Species Act, we have an explicit habitat description that applies to Blanding's turtles. And at the federal level, under our Species at Risk Act, we have also a recovery document for Blanding's turtles that again specifically outlines how we define their critical habitats. So to overview the results here, so for the population ecology component, we captured a total of 56 Blanding's turtles at the proposed quarry site. And then we did a mark recapture population size estimate and estimated approximately 80 turtles to be at that proposed site. And then we calculated the population density based on the suitable wetland habitat available and came up with a calculation of about 1.84 turtles per hectare. And we compared this density estimate to other estimates in the country of Canada based on the government document that outlines the status assessment for the species. So the Committee on the Status of Endangered Wildlife in Canada, we looked at the report produced for the Blanding's turtle. And as it turns out, this is one of the highest densities for the species in Canada. So obviously a very healthy population. In terms of the spatial ecology component, we outfitted 29 turtles with radio transmitters over the course of 2 field seasons. Here's a Blanding's turtle here on the left, and you can see the radio transmitter there mounted, glued onto the carapace at the back. And then Gabby and her team would go out and radio track the movements of the turtles. We also used GPS data loggers to obtain some fine resolution information on nesting habitat and nest site locations. So to move to that nest site information, so the first piece here, we found 15 nest sites. Here's a female Blanding's turtle on this rock outcrop. And you can see that there's a crevice in the rock here, and there's some soil and there's some lichen gathered there. And it turns out that in this area of Ontario, all the turtles nest on these rock outcrops. It's not your sort of typical expectation about nest sites, but indeed, we found 15 nests and using a combination of visual encounters, radio telemetry, and GPS technology, and game cameras as well. And so then what we did was plot those nest sites on a map in regards to the proposed quarry boundary. So outlined here in blue is the proposed quarry footprint. And then the black dots with the red circles, the red buffers around them, those are nest sites. And so clearly there are critical habitats with respect to nesting sites within that proposed quarry boundary. Similarly, for the hibernation site identification, we identified 12 hibernation wetlands over 2 winters, and that's 47 turtles that we made observations about at hibernation sites. Here's a picture of a Blanding's turtle through the ice. Here's the radio transmitter antenna from that animal. And so similarly, we then plotted those overwintering locations and wetlands with respect to the proposed quarry footprint. And again, it's pretty obvious that there are critical habitats used for overwintering that lie within and directly adjacent to that quarry footprint. So the third piece of what we did was to apply the provincial and federal legislation that defines habitat for this species. So on the left, I'm showing how it works for the Provincial Endangered Species Act. So, and I'll overview it for you in a nutshell. So here's a Blanding's turtle location. This happens to be a nest site, which is considered Category 1 habitat. So that is critical habitat that has the lowest tolerance to alteration or destruction. And then a 30-meter buffer is drawn around that to just protect the area. And then from that observation point, you draw a 2-kilometer radius circle around that. And any wetlands that are within that 2-kilometer radius are considered Category 2 habitats, the wetlands that are important to the animal's persistence and have a moderate tolerance to alteration. And then a buffer, a terrestrial buffer of anywhere from 30 to 250 meters, depending on how conservative you wish to be, are drawn around those wetlands. And then that whole grouping, now Category 3, 2, and 1 habitats are the habitat description that are deemed important for those animals. The federal system works quite similarly. You have an observation of a Blanding's turtle. You again draw a 2-kilometer radius around that. And then any wetlands within that are considered to be critical habitat. And again, a buffer is applied. In this case, it's a 240-meter buffer. So it's similar to the 250-meter maximum buffer that can be drawn at the provincial level. So very similar protocol in terms of how the habitats are defined for this species under the legislation at both the provincial and the federal levels. So now applying our radio telemetry data and observations to the mapping exercise. So this is the Provincial Endangered Species Act with all the habitats mapped. So again, nesting and hibernation sites are that Category 1 habitat, those least tolerant, and then through the wetlands and the terrestrial buffer. So when you categorize all those habitats here, and again, in the context of that proposed quarry footprint, which is about 115 hectares, approximately 60% of that proposed quarry site would be categorized habitat for Blanding's turtles. If you then apply the more conservative version, which is the higher buffer of the terrestrial habitat around wetlands, you now basically have 100% of the quarry footprint is deemed habitat for Blanding's turtles. Similarly, when you apply the federal critical habitat mapping exercise, the scale is much larger because just the way the categorization is applied. But again, if you look at the outline of the quarry, you can see that basically 100% of that quarry footprint is considered critical habitat at the federal level. Now, we applied both provincial and federal legislation to this particular site because I mentioned it's Crown land or public land, which means our Provincial Endangered Species Act applies. But it also sits within the Robinson-Huron Treaty lands for First Nations in Canada. And on First Nation lands is where our Federal Species at Risk Act applies. So both pieces of legislation are applicable in this particular case study. Okay, so it's pretty obvious from these this mapping exercise that the quarry proposal should be rejected if the spirit of those pieces of legislation are upheld. If we consider the Endangered Species Acts, both federally and provincially, it seems it's not a good place to build a quarry. But what's interesting, so I mentioned that at the outset, I offered to collaborate with the consulting company and the quarry company, but unfortunately, upon seeing our data, which we readily shared with them, we provided them with our data, the quarry company and their consultant launched a defaming attack on our careers by widely disseminating in writing accusations of academic misconduct, conflict of interest, and data fabrication. It was an extremely trying period for us, for the research team. But I'm glad to say that after several exchanges between lawyers, a letter of apology and a retraction of the accusations was received from the consultants. But at this point, to my knowledge, the quarry decision still has not been made, and it remains to be seen whether the science that we've provided or politics or money will prevail in that permitting decision for the quarry. So I have an idea about how maybe we could make this work a little better. And I think the way it works in Ontario is probably not all that different from the way this works in other places. So still the idea that the developer would hire a consultant, but that you add this collaborative approach. You add the academic research partner and bring in graduate students to collaborate on that environmental impact. So consultants have various expertise across their companies, but they don't have expertise in absolutely everything. And so by bringing in an academic researcher, and particularly a graduate student, who you then are training the next environmental professionals, you get a dedicated person who's very focused on that particular research component of the assessment. And I think you end up with a really stronger package at the end, a really stronger set of data, which you can use to then make really good decisions. And so then that assessment is still passed to the regulator, and the regulator then makes the decision about that. So basically, we are advocating for this data-driven and evidence-based decision-making approach. And I think from the perspective of the developer, it could mean there are fewer of those unwanted surprises, oodles of endangered species in a particular site, because you can start the process earlier and collect really good data earlier in the process of applying for a permit, for example. And so the developer could decide to change where the proposal for the quarry or whatever it might be might happen to avoid those endangered species. And so ultimately this approach could save time and money. And if you would like to know more about our story, it's published in Global Ecology and Conservation. And with that, I'd be happy to take any questions.
Jackie, we're going to wait just a minute. As of yet, we don't have any questions, but we're going to let that time lag to the live stream play out. And that was a great talk, and I really enjoyed seeing all of your data laid over the site. It was great. Let's see. Everyone's just giving you great compliments on your presentation. Here is one question coming in. What kind of stone were they going to mine at that proposed site?
So it's Canadian Shield granite rock outcropping. And so trap rock is a specific type of rock, and that's sort of deeper down from the surface layer in those Canadian Shield types of structures, I guess. And the intention for the aggregate to be extracted would be for road development. It's used in the asphalt on roads.
Gotcha. Second question. Do you worry about political pressure applied to the academic side of a formal collaborative relationship like you were proposing?
Yeah, so it's a difficult situation for sure. I feel like an academic researcher could be more arm's length and collect the data, and then simply, and has been our approach, to then simply provide the data to the decision makers to use. It's not my role to make the decision, but I think it's our role as academic scientists to provide the data to the people that are making the decision. So I think there can be a pretty good separation from any political aspects there. Question 3 says, what was the proportion of successful fixes on the GPS loggers, being that they're aquatic turtles? That's a really great question. And so to get information on nest sites, we did use cameras, visual surveys, like staying out in the field in a tent and following turtles, the VHF and the GPS. The GPS loggers were not great. We did get some information from them, but at this point, I'm a pretty strong advocate for VHF radios and being on site to actually collect the data. We could not rely on the GPS loggers alone to collect the data that we needed. Question 4, to what extent are you collaborating with advocates for other species ecosystems in developing policies for development projects? So I mean, I'm not developing policies, but I am providing data so that others can again, use those data to make the appropriate decisions. I do want to remain arm's length from those projects. And that's it. Thank you.
Hello, this is Lisa. Is it my turn to go yet?
Sure is. We can see your presentation and hear you perfectly.
All right, great. So before I begin, I'd like to offer a quick disclaimer. I'm not a herpetologist, although I have necropsied over 100 turtles in this project. I'm a wildlife veterinarian with a background in epidemiology. In my current position with the Florida Fish and Wildlife Conservation Commission, or FWC, I frequently investigate wildlife mortality events, which leads me to the story that I will be sharing with you today. This research has been performed in collaboration with veterinary pathologists and virologists from the University of Florida and NOAA Fisheries. I'm not going to speak about the virus discovery aspect in my talk. Instead, I'm going to focus on some of the clinical signs and gross pathology, as well as our field investigation efforts. I'll start by introducing the Florida softshell turtle, which is found in the 4 southeastern states of Alabama, Florida, Georgia, and South Carolina. Within Florida, the Florida softshell is found statewide, except for most of the Florida keys. Its habitat includes most permanent and semi-permanent bodies of water, and it will commonly move across land between water bodies. It has a mainly carnivorous diet and will even scavenge on dead animals. Adult males and females are sexually dimorphic, with females being much larger than males. In fact, females can get quite large. The largest Florida softshell female on record weighed in at 96 pounds or 43.5 kilograms. However, females may reach sexual maturity at only 7 to 10 pounds of weight, which is possibly between 4 to 7 years of age. In contrast, males may reach sexual maturity at the much smaller size of less than 1.5 pounds and a suggested age of 2 years. I should point out that this information comes from a very limited number of studies in geographically focused regions. The Florida softshell nests from March to July, and it can lay 4 to 6 clutches per year, consisting of 9 to 38 eggs. This species has been categorized on the IUCN Red List as a species of least concern, although population trends for the species are currently unknown. In Florida, commercial harvest of this species took place until 2009. Then in 2016, the Florida softshell, along with the smooth softshell and the spiny softshell, were added to the CITES Appendix 3 list. Thus, the international trade of the species is now monitored. Florida state laws prohibit the removal of any softshell species from the wild during the months of May through July, which correspond with the peak nesting season. But outside of this protected period, one softshell per day per person may be collected from the wild for personal use. However, wild turtles and their eggs cannot be collected for sale. In general, very little is known about the population structure and current trends of the Florida softshell, with only a few scientific studies having been performed. One such study suggested that it may take up to 20 years for a population to recover after being reduced. So in March of 2018, FWC learned that numerous sick and dead Florida softshell turtles were being found along the southern region of the St. Johns River. This is the longest river in Florida, and it is unique in that it flows from south to north. The St. Johns River is a hotspot for fishing and ecotourism, and it was really the shared concerns of the people who worked on this river that initially prompted our investigation. From March 9th through May 23rd, FWC performed 8 airboat surveys along an approximately 30-kilometer stretch of river and associated lakes. Several softshell carcasses were collected for necropsy and laboratory evaluation during the first few surveys. However, the condition of these carcasses was often not suitable for laboratory evaluation due to scavenging and decomposition, such as you can see in this top middle photo. Therefore, we moved to identifying sick animals in the field and bringing them into the laboratory for humane euthanasia and prompt necropsy. Sick turtles could be recognized by a combination of several features. In the most severe cases, the turtles were basically immobile. They sat in shallow and muddy water with their necks stretched out along the ground, and these animals exhibited minimal response to being handled. In the more mild cases, the turtles could be easily captured and were much more docile than expected. Their eyelids were often shut, swollen, and ulcerated, as seen in this upper right photo, and skin lesions were commonly apparent. In May of 2018, FWC released our first press release regarding the mortality event. The release asked public citizens to report findings of sick and dead turtles to our established fish kill hotline reporting system because we did not have an existing mechanism in place specifically for reporting sick and dead turtles. Fish kill hotline staff then passed turtle-related reports on to my wildlife health working group. One challenge that we faced in these initial stages of the investigation was that the delay in the transfer of information between working groups made it difficult to provide a timely response and collect carcasses when feasible. By late June 2018, turtle mortality reports appeared to have paused. I should emphasize that although we suspected that the mortality events were likely due to a virus, at this point in our investigation, attempts to identify a virus had been unsuccessful, and we did not yet have a diagnosis. So although the reports had died down, we took a cautious approach and assumed that the disease might have a seasonal association and could reappear in the spring of 2019. Our goal was to improve our reporting mechanisms and our response time so that we could try to catch cases earlier and more successfully retrieve carcasses for evaluation, especially from new areas. To do this, we set up 2 new reporting mechanisms, a designated hotline number and an option for reporting through the FWC Reporter app, which was entering its 2nd year of implementation. We posted signage at approximately 100 public boat ramps along the St. Johns River to alert the public of our investigation and provide information on how to file reports through the hotline and the app. On this slide, I will walk you through the Reporter app process, where the user goes through a series of screens to select the correct options for reporting. On screen 5, the user can select if he or she is at the location of the animal. And if yes is selected, the GPS coordinates are captured. The user can then take a picture and attach it to the report or upload a photo that was already taken. The user can then add additional text describing the situation before sending the report. I immediately received the report in my email inbox along with several other people on our wildlife health team. The app is currently undergoing some modifications to make it more user-friendly based on our user feedback. So working with our collaborators at the University of Florida School of Veterinary Medicine and at NOAA Fisheries, in December of 2018, we eventually learned that the mortalities were caused by a novel virus in the order Bunyavirales. We have been calling this turtle bunyavirus. In necropsy, we found that most of the virus-positive soft shells were mature adults. Of course, larger animals are easier to find and less likely to have been predated upon, so we don't know if the size discrepancies are real or based on a collection bias. Infected soft shells were generally in good body condition with adequate to abundant fat stores. In this upper left photo, you can see abundant bright yellow fat in the axillary region of this female soft shell. However, the gastrointestinal tracts were essentially empty, indicating that the turtles had not recently fed. Females had shelled eggs or follicles. What was most striking was the severe yellowish green or gray colored ulcerative plaques that coated the oral cavity and the cloacal region of most infected soft shells. In fact, the finding of these plaques initially made us suspect a Rana's virus or a herpes virus, but PCR tests for these known viruses were negative. In the center photo, you can see that the tongue and the gular region have been reflected and that the plaques extensively cover the area of the oral cavity. Although I'm focusing on soft shell mortalities in this presentation, it is important to share with you that as we progress through our investigation, we eventually realized that cooters and sliders were also infected with turtle bunyavirus. However, the necropsy picture was a bit different in cooters. The cooters were very emaciated. In this photo, you can see the enophthalmia, which is the recessed appearance of the eyeball in the bony orbit. This is likely a combination of dehydration and loss of retroorbital fat. Cooters also often had mucoid bubbles emanating from their eyes or from their nares. And in the lower right photo, you see the tail end of the turtle, and the scalpel blade is pointing to the blackish green colored fat. The fat changes in these animals from a bright yellow to this dark color as it gets utilized by the body and becomes atrophied. Interestingly, infected cooters only had mild oral plaques and did not seem to have cloacal plaques. I'll wrap up by sharing some of our preliminary results regarding the distribution and spread of this virus in Florida. In this slide, I have a series of 3 maps representing reported Florida softshell turtle mortalities by county for 2018, 2019, and 2020. For each year, the counties that are in red are those in which softshell turtles have tested positive for turtle bunyavirus. The yellow counties are those where we have received reports of sick and dead softshell turtles. In some of these yellow counties, we have been unable to collect and test turtles for the virus. In other of the yellow counties, we have tested a few turtles, but they have so far been negative. The red hatch line counties are those where softshell turtles were found positive in 1 year, but positive turtles were not found in subsequent years. And finally, if there is a yellow dot in the red hatch line county, it indicates that although we have not had any more virus positive softshells in that county, we have continued to receive softshell turtle mortality reports. What is immediately apparent in this map is that the virus positive hotspots in the east central region of Florida Peninsula are not going away. In addition, based on mortality reports alone, there is some evidence that this disease may be spreading across the landscape. For example, let's take a look at the adjacent counties of Brevard and Indian River. Brevard County was one of the first counties where turtle bunyavirus was detected, but it wasn't until 2020 that we began to receive reports of sick and dead softshells in the Indian River County, which is just to the south. Over an approximately 4-week period, at least 15 dead softshells were found at a single location in a pond in an urban park. We were unable to obtain fresh turtles, but we were able to get one severely autolyzed animal from this mortality event. The internal viscera were missing, but cloacal plaques were still evident. I do need to point out that there is likely an element of reporting bias in some of these reports. FWC has periodically put out press releases that are picked up by the local media sources and tend to generate an influx of reports. Therefore, it is likely that the mortality events in urban areas, such as retention ponds, are overreported as compared to mortality events that occur in these less populated areas. For example, in the urban areas, we receive reports from lake management companies who come across dead areas. And we also have established contacts with citizens who continue to report events in their local areas. So far, our research has been very opportunistic, and we have a lot of work to do to understand the epidemiology of this emerging disease. And we're still analyzing some of the data, but I can share with you that in 2018, we've determined that we had approximately 230 sick and dead soft shells reported, and 90 of those came from our surveys along the St. Johns River. And to date, of the turtles we've submitted for testing, 25 soft shells have tested positive. So I'll conclude with leaving you with this sobering thought. Florida softshell turtles are facing a new threat. Turtle bunyavirus population impacts are unknown, but may ultimately be locally severe. And I'll see if I can get my chat box up if there are any questions.
We do have two.
Okay. Question 1, are bunyaviruses found in other species of reptiles or birds? This particular bunyavirus is only that, so far as we know, has been found in the specific turtle species that I mentioned, which are the Florida softshell turtle, the peninsula cooter, the red-bellied cooter, and the red-eared slider. But there are many other types of bunyavirales that are found across different taxa. So that would be a better question for virologists to know all the details there, but there are many different types of bunyaviruses. And question 2, any reports of invasive softshell species tested positive? We have not received any other softshell turtles that have been reported dead for testing. It's only been Florida softshells. We haven't received any reports of smooth softshells or spiny softshells or other two native softshell species, and we have not received any reports of exotic softshell species here. And I don't see any other questions.
And we're going to hang on just 1 second to see if we get one more in. Up next, we're going to hear from Claudia Santori. And it doesn't look like we have any other questions. Oh, hang on a second. No, that's it.
All right, thank you.
Lisa, can you stop your screen share?
Hi everyone, is my audio okay?
Absolutely, looks great.
Brilliant. So hi everybody, my name is Claudia and I just completed my PhD at the University of Sydney. And I'm here today at this very early hour in Sydney to present some of the highlights of our recent work on the scavenging role of freshwater turtles in Australia. Okay, so to start by giving you some background information, Australian freshwater ecosystems are currently suffering from a variety of conservation issues. A prominent one over the last couple of years has been the occurrence of devastating fish kills, which have seen the death of hundreds of thousands of fish. The Menindee fish kills last summer caused the death of potentially more than a million fish. And these are caused by a series of factors, including water overextraction coupled by very dry weather. Another issue is, which has been going on for a few decades now, is the invasion of the European carp, which is now the most abundant fish in many Australian waterways and has caused the decline of several native species. More than a million. Sorry, I can hear some feedback here. I hope it's coming around okay. Yeah, so the Australian government has been working on the release of a carp herpes virus to control the number of these fish. However, many fear that the release of this virus will cause a fish kill of extreme proportions with exceptional consequences to the water quality. But where are turtles relevant in all this? Well, turtles cover a wide range of ecological roles. For instance, they are crucial seed dispersers, and they are also important for soil dynamics by digging impressive burrows. They can also be very abundant predators and prey, which makes them very important links to many food chains. But of particular interest to the environmental issues that I just mentioned, they are scavengers. So they eat basically dead matter and dead animals that are in the water. Their scavenging role is strengthening their food web and is important for nutrient cycling, and is particularly crucial for the straightforward removal of carrion from the water. Carrion left rotting in the water can in fact cause an increase in nutrients and lead to algal blooms and decrease water quality, which can then cause or exacerbate fish kills. However, their scavenging role, the scavenging role of freshwater turtles has never been experimentally quantified. So we studied the scavenging role of the 3 species of freshwater turtles that live in the Murray-Darling Basin. The Murray-Darling Basin is the largest in Australia. It's found here, is the great area in the map, and is a crucial source of fresh water for several major cities, such as Adelaide here, as well as for agriculture and industry. And the basin is also very full of carp, and it has seen an increase in fish kills over the past few summers. So these are the 3 species of freshwater turtles that live in the Murray-Darling Basin. We have the broad-shell turtle, the eastern long-necked turtle, and the Murray River or short-necked turtle. These are very long-lived species, and they have undergone a serious decline over the past 40 years. And they all have carrion as part of their diet. In fact, about 25 years ago, it was estimated that they used to consume more than 400 tons of carrion per day, which is a staggering amount. However, now that they've been declining, their role is likely being lost. So for this study, we had 2 main questions to address. The first is carp decomposition affected by turtle scavenging? And does scavenging by turtles affect the change in water quality parameters after a simulated fish kill? So we addressed the first question by conducting a large-scale field experiment in the state of South Australia, while we answered the second question by conducting a mesocosm or controlled environment experiment at Western Sydney University here in the state of New South Wales. So for the field experiment, we sunk a series of carp carcasses, 4 sites along the River Murray. The carcasses were made either not accessible to turtles, so protected by this mesh that you can see in the picture, or they were accessible to turtles, so they were not protected by any mesh. The mesh was large enough to allow access to crustaceans and other smaller scavengers, but obviously prevented turtles from being able to eat the carp. We then measured the carp mass daily to assess the rate at which they were being scavenged. We also quantified turtle abundance by calculating catch per unit effort at each site. We did this to eventually compare the rate of carp carcasses mass loss with turtle numbers at each site. We also conducted a series of observations from wetland banks to monitor whether other possible scavengers, such as birds or water rats, were present and approaching the carcasses. So we conducted a field experiment to assess whether carp decomposition was affected by turtle scavenging. And indeed, we found that the accessible carp, so the black dots here in the graph, where we have day on the x-axis and carp mass on the y-axis. So the accessible carp lost more mass more quickly compared to the non-accessible carp, which is in red. And here's a photographic example of a non-accessible carp, which remained more or less the same after 10 days, whereas a accessible carp was pretty much gone. We also found that the rate of carp mass loss was related to the turtle catch per unit effort, with accessible carp represented by the black dots and the non-accessible carp represented by the red dots here. We've got total catch per unit effort on the x-axis and a rate of carp mass loss on the y. And here you can see that the accessible carp lost more mass at sites where there was a higher turtle catch per unit effort. And also from our observations from the wetland banks, we did not see any birds or water rats approaching the carcasses, so we are confident that what we observed was turtle scavenging in fact. So our experiment supported the hypothesis that turtles consume fish carrion at a faster rate than it would otherwise decompose in their absence, and their abundance at a site is linked to how much carrion is removed at that site. So concluded this field experiment, we conducted the mesocosm experiment that was aimed at exploring the link between scavenging and water quality. So here for this experiment, we had 10 mesocosms or experimental ponds, and you can see our facility in this picture here. So for the experiment, we placed four short-necked turtles in 5 ponds, so half of them, and half ponds had no turtles. We then placed 2 dead carp in each pond, about 5 days apart, and measured daily water quality parameters. So the parameters measured were dissolved oxygen, ammonia, phosphate, and conductivity. And this experiment confirmed the ability of turtles to remove carp very quickly from their environment. And here we have another photographic example in a pond with turtles. The carp was pretty much gone at day 5, whereas in ponds with no turtles, there was no change for a really long time. And the same is depicted in this graph here, where we have day on the x-axis and decomposition percentage on the y-axis. And the black dots and lines are the decomposition of carp in ponds with turtles. And the carp at the ponds with no turtles are in the red. And you can see how in the ponds with turtles, the carp decomposed or were removed a lot faster compared to the ponds with no turtles. Regarding the water quality, we computed a principal component analysis to encapsulate all variables at once. This is a graph showing a fluctuation of PC1 over time. We got the day on the x-axis, and here we've got the loadings of PC1. So a positive load means that the parameter changes positively with the PC. So if the PC goes up, then these go up as well. The negative load is the opposite. So if the PC goes up, then these go down. As we can see, the water quality in the ponds with turtles, so the black line, thanks to the quick removal of the carrion, they returned to pre-carp condition much more quickly compared to the ponds without turtles, where the water quality kept worsening for several days. So this experiment provided an answer to our second question, with the scavenging of turtles buffering the change in water quality. So just to recap, all in all, we found from our field experiment that turtles are important scavengers in the Murray-Darling Basin and prevent the worst effects of fish rotting in water quality. Since we detected a link between turtle abundance and their carrion removal service, as turtles continue declining, we might see more and more issues with water quality. And I just wanted to acknowledge everybody that helped or participated or contributed to this project. And I'm ready to take any questions. Thank you.
We will hang on just a minute and see if we have any come through from YouTube. Up next is going to be Devin Edmonds, though, after we're done here. And thank you. That was great to see how much they took care of those fish and helped keep systems clean.
Thank you.
Okay. Was there a difference between species as scavengers?
Sorry, could you repeat that, please?
Was there a difference between species as scavengers?
We have not quantified that in the field because having just put the carp out there, it was pretty much a free-for-all for all the 3 species. But we know that the short-necked turtles have a much larger proportion of their diet as carrion. So we think that definitely shortnecks are the largest scavengers out of the 3, and that's why we chose them for our mesocosm experiment. However, yeah, in the field, they could all have a piece, so we're not sure for that.
All right, and I think that's going to be the only question. So thank you very much, Claudia. And
Thank you.
Next up is Devin Edmonds.
Okay, everything seemed to be working all right?
Absolutely.
Oh, good. Okay. My name is Devin. I'm a graduate student at the University of Illinois, and today I'll be sharing my master's work with you on ornate box turtles. So as I imagine a lot of you already know, ornate box turtles are kind of a turtle of the prairie. They're found throughout the Great Plains. The populations that I worked with in Illinois are at the far northeastern edge of their distribution. And here they're one of 7 threatened or endangered turtle species in the state. A lot of the sites where ornate box turtles are known from in Illinois are sites where it's not clear if there really are populations there, or maybe there's just a few kind of old remnant turtles hanging on, or sites where somebody found a turtle once 10 or 20 years ago. So I ended up working at 2 populations in northern Illinois. And these were sites where people know that you can still find ornate box turtles if you look for them, but it wasn't really clear if they were maybe populations that were already in decline and in need of some conservation attention, even though there are still turtles there, or if maybe the populations are stable and are doing okay. So my 2 research questions were, first, what are the demographic traits of these 2 ornate box turtle populations? And then are they stable, increasing, or maybe declining? And to figure this out, there are kind of 3 pieces of information that we want to get at. First, I want to know how many turtles are there now? So what's the population size? And then I need to figure out reproductive output. So how many new turtles are coming to the population? And then to get an estimate of how many turtles are leaving, looked at survival or death. And with these 3 pieces, I was able to look at the future abundance for both sites. So the first piece of information, reproductive output, to get at this, I radiographed 70 individuals from 7 sites in 5 counties, most just at those 2 sites. And it's actually kind of tricky. I'd never radiographed turtles before this project, but you really have to time it right. If you radiograph females too early, even if they're gravid, their eggs aren't calcified yet, and so you can't see the eggs on the x-rays. And if you radiograph too late, of course, and the females have already started laying, your data is not any good because you miss it. So you have to kind of just time it just right and get in there at the right time of the year, end of May or early June. I ended up coming up with a mean clutch size at the first site, site A, of 2.5 eggs, and a mean clutch size of 4.2 eggs at the second site, site B, so a little larger. And it makes sense, turtles at site B are themselves a little larger on average. The second piece of information that I needed to learn was annual survival. So we carried out capture, mark recapture surveys. We gave each turtle an individual ID with a shell notch. And we used wildlife detector dogs to locate them. I know maybe some of you have worked with these exact dogs. These are John Rucker's dogs, and they really help out. I think there was a presentation last week or the week before that on just how effective they can be in that case in, I think, South Africa. And we certainly, they made a big difference in our surveys too. You know, one of our sites, site B, you can go out there and yourself and look for a whole day, and you might come back with one ornate box turtle. Whereas if you go with the dogs for a few hours in the morning, you can come back with 15 or 20. So they were really helpful. So to figure out annual survival, we looked at data from 1999, 2010, 2018, and 2019 at site A. And at site B, we used data from each year from 2016 through 2019. And this gave us 411 captures of 295 individuals over 20 years at the first site, and 279 captures of 181 individuals at the second site. We didn't find any evidence that the sex ratio differed from 1 to 1, so like an even sex ratio. And then I estimated survival and compared different models with sex or stage, juvenile, adult, and time. But the top model for both sites had survival constant. And at site A, we had a pretty good estimate. I came up with an estimate of 0.97, anywhere from 0.94 to 0.98 for annual survival. Site B, on the other hand, was a much less precise estimate and a little lower annual survival of 0.86, which will make a difference, just see in a minute. And then the third piece of information was starting abundance, so population size now. And I used a Papan model to estimate population size with the same covariate structures as the top survival models. And that came up with an estimate of 429 turtles at my first site and 278 at the second site. So how does this compare to other sites that are published in the literature? Well, I looked at density, and it looks like the density of ornate box turtles at that first site, site A, was some of the highest of any site that was published in the literature, where at site B, it was kind of towards the low end with 2 turtles per hectare. So with these 3 pieces of information, reproductive output, annual survival, and starting abundance, I then worked to kind of project population persistence. So kind of with the current demographic conditions, what is population growth, and how might population size change under different scenarios, under average, worst, or best case scenarios? I didn't have any site-specific data on nest survival or breeding frequency, so I had to substitute some information from the literature. These are all the demographic parameters I used in the analysis, but I was able to use clutch size and adult survival and a few other things that I estimated. And this resulted in at site A, it looked like maybe a stable population. So population growth there in the average case was 1, so stable. And in the best case, maybe growing at 3% a year, or in the worst case, declining at 5% a year. On the other hand, at site B, at the second site, even in my most optimistic model, looked like the population was declining at 3% a year. But Oh, just to show you an example of what this kind of looks like. This is the first site, and you can just kind of see under the average scenario, it's kind of stable, a straight line, projected through time. And for the second site, the population declines even in the best case scenario. But I think really what this says is not necessarily that site B is a population that's crashing or declining, but really that we just need better data. My estimates of adult survival there were not very precise. And so in my most pessimistic models, I used adult survival of 0.69, which is very low. And in fact, was lower than the survival from the literature for juveniles. So really what we need is to just kind of refine survival estimates for the second site to figure out if it actually is declining and needs some conservation attention, or if maybe something else is going on. So if you remember, both sites had 4 sampling intervals. But at site A, I had 20 years of data starting in 1999, and at site B, I only had 4 years of data, and that made a difference. Site A also had a greater number of recapture turtles. The density of turtles at that first site is much higher, so you just come across turtles more often, and so there are more recaptures. And so the survival estimates were, for site A, were more precise than at site B. However, there's other ways to estimate annual survival. For example, with radio telemetry, you can use known fate models and get some survival estimates in a couple years. Or at site B, you could continue these annual surveys for another few years, and that would probably tighten up the survival estimates. But either way, it requires a greater commitment of funding and personnel and equipment, and I think that's probably like the common theme for all of our projects, since we're all working with turtles, is that to understand what's going on demographically in these populations, we need more resources. And then just to kind of wrap things up, one thing I thought to point out, maybe somebody else's master's project down the line, for not just ornate box turtles, but probably for most turtle and tortoise species out there, is hatchling and juvenile survival seem to be 2 missing pieces. And with ornate box turtles, future research you could follow gravid females around, guard the nests until they hatch, and then monitor the survival and habitat use of those hatchlings. And that would actually be really helpful for informing these demographic models. And it might also help answer questions like, why are young turtles so difficult to find? Is it because they have higher mortality or occupy different microhabitats than adults, or is it just because they're small and just difficult to see, or all of those? So with that, I'd just like to acknowledge all the funding agencies and supporting institutions and collaborators that we worked with the last few years, and I think there should be time for a few questions if there are some. Get the chat open.
You do have 2 in there.
Oh, okay. So the first question is, were you finding that John's Boykin Spaniels were consistently picking up hatchlings and juveniles in addition to adults? Good question. No, they certainly do find hatchling or juveniles. We really had very low, we didn't detect very many hatchlings at all with or without the dogs. And it was actually a little tricky because, we didn't, with small turtles, they can be injured easily by dogs too. So when they would get a juvenile, it's a pretty urgent situation to get over there and get the turtle out of their mouth. But yeah, hatchlings and juveniles are just tricky to come across. So, but yeah, I think we were definitely sampling the adult or larger turtles, larger juveniles too, more than we were getting at the smaller turtles. Okay, and then the second question, At site B, at the second site, would there be any intervention available if the population does decrease drastically in the future? Yeah, that's a good point. You know, what if that population was declining, what might have caused it? And, you know, the greatest threat that ornate box turtles face here in Illinois, probably throughout the range, is habitat loss. Both sites we worked at were protected areas. However, other things that can contribute to decline, for example, if you increase adult mortality at all, if that was the issue, that adult mortality was very high, so, in that case, that could be caused by vehicle use in the habitat, or if the habitat was kind of, some of these sites are kind of mixed with agricultural fields, and if the turtles are going in and out of a cornfield and at risk of being hit by a tractor, that could be a problem. So, you know, I also conducted a sensitivity analysis, and which I didn't show you here because I was kind of pressed for time, but really, you know, ornate box turtle populations are, like pretty much all turtles, are most sensitive to increases in adult mortality. So if you can protect those adults, especially adult females, that would really be key to making sure these populations continue to exist. I have a question 3. Are you looking into any local extirpations because of collection for turtle races? Interesting. I don't, that's a good question. I'll look into that. I don't, you know, I feel like I have this sense that that's something that might have gone on here 10, 20, 30 years ago, but I should double check to see what's happening now. I actually don't know, but that's a good thought. Thank you for bringing that up, Amit. And then the 4th question, you may have already mentioned this, but did you find any nests? And although we had some females with receivers on them, I didn't go out. Ornate box turtles tend to nest at night, especially rainy nights. And I tracked them during the day, usually in a little more pleasant weather, but you know, so we didn't actually detect any nests. I think in the work the last 3 years that I was involved in the project, I mean, between both sites, I think there's less than 10 or so hatchlings, turtles that we would call less than a first year. So, you know, really there was a bias for adults. That's what we were detecting. So, okay, I guess that's it. Thanks a lot for listening.
Okay. Can you see well my screen?
Absolutely. Everything looks perfect.
Yeah. Hello, everyone. My name is Eduardo Reyes Grajales, and today I'm going to present this study. The title is Population Ecology and Morphology of the Central Chiapas Mud Turtle. But first, I want to say thank you for all the TSA team for the great job to do this virtual symposium. Many thanks. Well, the importance of studying ecology and morphology lies in the incorporation of essential information to carry out management and conservation projects and understand the phenotypic variation of a population or a lineage. In this context of species that are poorly known, this is so relevant. In this way, Mexico is the second country with the highest diversity of turtle in the world. In this country, Chiapas is the state with the greatest diversity of the turtle nationwide. However, in the southern region of this country is where historically fewer studies have been carried out. As we can see, a lot of study in the center and the north of the country. One clear example, in another hand, the genus Kinosternum is the group that have more taxonomic uncertainties remain. One clear example about this is Kinosternum abaxillare. Since even though this turtle was described more than 19 years ago, focus studies are scarce. I want to mention this from here. I will only refer to kinosternids by their specific epithet, so as not to repeat kinosternum, kinosternum, kinosternum. So basically, this work focused on the analysis of the ecological and morphological aspect of a maxillary in wildlife in one locality in Chiapas. We estimate population size, density, biomass, sex ratio, and we determine the population structure based on 6 classes. We describe the morphological characteristics of each age class of a maxillary, and we analyze the morphological characteristics of each sex only for adults of a maxillary. My study site was in a portion in the Central Depression of Chiapas. I work in 3 permanent ponds, all surrounded by livestock and cultivation area, even though 2 serve as a seaward outlet. The rain season is from May to October, as we can see in this graphic. The remaining months are the dry season, like November to April. Recapture study was conducted monthly from March of 2018 to February 2019. In these pictures, you can see the traps that I use, and in this order, the order of each pond, I use a 5 net and folding box. Basically, per pond, I use a 1 5 net and 2 folding box. In addition, every turtle trapped the first time was marked. In addition to differentiate between each class categories and sexes, we follow the description made by Iverson, Legler, and Vogt. Considering the number of individuals captured and the percentage of recapture to estimate population size, we use the Jolly-Sieber model for open population. Density was estimated dividing the population size and the surface area of the pond. Biomass was estimated multiplying density by mean body mass of all the turtles captured. And to analyze the population structure, I did categories of 19.9 of capara's length. And finally, sex proportion was estimated using a chi-square test, using only data from adults. To do the description of the morphological characteristics, we use 2 ways. First, a qualitative description using a photographic and written records, and the second one using a quantitative description, obtain the mean, standard deviation, and the minimum and maximum volume of all the characteristics, as we can see here of the region dorsal, ventral, and the plaster formula. Unfortunately, due to the amount of the data, the presentation time, I will not be able to display the data. However, I will only present the general discussion and conclusion about this topic, about morphology. The data will be able in the next publication about this work that we are doing. Finally, the plaster formula was obtained ordaining the mean from the largest to smallest plastral skewed. Morphological difference between sexes was made using a t-test for parametric data and a human weighting for non-parametric data, only for adults, as we can see in this category. Well, in this study, we have 168 market turtles and market during the sample period, and 64 was recaptured. Here we can see a summary of the total of the catches of each size and sex class. In this graphic, we can see the number of individuals captured by month, and here are the results for population size, density, biomass, and sex ratio. Captures of a maxillary peak during the early raining season can be attributed when individuals are emerging from estivation and returning to their aquatic habitats to feed, reproduce, and restore the balance, as we can see in this month. But the December and January peaks in this can be attributed to the recruitment of some turtles from seasonal ponds to permanent ponds, where some individuals begin to estivate due to the lack of food or space. The population size, density, and biomass were similar to other kinosternids like Integrum, RRI, and Sonoriense. The population size, density, and biomass present high values considering the size of the water bodies, which are approximately less than 0.1 hectare per pond. It's important to mention that this data agree with Iverson, where he points out that turtles are an important component of the ecosystem where they live. We report a bisect sex radio, a female bisect sex radio, which is not uncommon for other kinosterns, such as Kinosternum wahase, Kinosternum scorpioides, Scorpioides albuculare, Scorpioides, and Sonoriense. Our site has several unnaturally canopy openings caused by anthropogenic activities that could increase nest temperatures. In addition, population with temperature-dependent sex radio may be unable to evolve rapidly enough to counteract the negative consequence of global temperature change. Fortunately, female bisect sex radio is not as harmful as that of female, since one male can inseminate several females, which increase the offspring production. Our maxillary population structure was skewed towards larger individuals, as we can see in this graphic and as we can see in these numbers. A skewed population structure toward all larger individuals might reflect unstable population, following the comments from Giff and Amato in 2000. However, the larger number of adults and immature new reproductive sites suggests that this population could persist of many decades as long as anthropogenic pressures are minimized. Okay, the absence of axillary scutes in a maxillary is considering a diagnostic of this taxon. But we found one immature individual, 3 males, 3 females that had partially or complete axillary scute. We can see an example of this in this picture, that we can see the axillary scute in both sides. Iverson, in 2008, reported that in one population of a maxillary, less than 10% of individuals had partial and or complete axillary scute on one or both sides. This finding was consistent with our study, but we found less than 5% of all the individuals. In general, hatchlings have poorly developed plastron lobes. We can see the head, the legs, and the tail. What more? In general view, the carapace is strongly unicarinate, as we can see in this picture, and the marginal scutes have yellowfish coloration, as we can see in this part. Juveniles show evident recarination, as we can see in this part. Plastral lobes completely close the carapace, and sexual dimorphism is not evident, such as spotting patterns and big size, as we can see in this view of the head of this juvenile of a maxillary. Okay, adult males have a larger beak there are spots all over the head. In general view, the carapace is elongated, tricarinate, and the anterior and posterior marginal scute are more elongated, as we can see in this region and in this region. Adult females have a reduced beak, do not present a spot in the region of the beak. In general, the carapace is dome-shaped. The anterior and posterior marginal scutes are not elongated, as we can see in these pictures. In these 2 phylograms, we can see the taxa with which abaxillary is most related. Basically, abaxillary with species like Oaxaca and taxa from Scorpioides, as we can see in this part and in this part. However, our morphological, considering qualitative and quantitative characteristics, abaxillary shows similarity with Ertepes and Integrum. In the case of adults, considering both sexes, abaxillary present morphological similarity with Integrum and Oaxaca, following this literature. The plaster formula was similar in all the age and sex classes, as we can see in this table. In the same way, the plastral formula was different in other species that are closer with abaxillary, such as Scorpioides and Scorpioides crentatum. However, the plaster formula of abaxillary was similar with species like Ertepes, like Integrum and Sonoriense. Of 18 morphometric variables, about 30% has a significant difference between the sexes. In most of these characteristics, the females were larger. However, the size of the head was larger in males, as commonly happens in older Kinosternids. To conclude, we can say that this work represents the first focused and systematic work with a large sample size did with abaxillary. Apparently, these species have more activity in the raining season. The population size was larger, but unstable. Qualitative, all the size and sex classes looks like Scorpioides. Quantitatively, immature looks like Scorpioides, and adults like Integrum and Oaxaca. The plaster formula was similar in all the size and sex classes, and in this population, the females are bigger than males. From this work, I pretend include more samples and localities. I'm doing now a research to determine the real distribution in the Central Depression and the conservation status of this turtle. If I can have more grants or help, anything, I pretend to study some aspect like home range, reproduction, and diet. I want to thank all the people and all the national and international organizations for supporting this project. Also to TSA for organizing this necessary event, and to people interested in this topic. If you have a question and if I have a time, I will be happy to answer you. Many thanks. David?
Thank you, Eduardo. We're going to hang on just another minute and see if we get any questions over from YouTube. We're going to be hearing from Donnell Gasparini. And thank you very much, Eduardo.
One question here in YouTube.
Yes.
Well, I don't know if I can say something about this diet, because I don't study in some aspects like I say the dietary habits, what kind of functions this pig have in the population of abaxillary. But maybe in the future I can send you something about this topic. Thanks.
Good deal. Thank you, Eduardo. Are you ready, Donnell?
Okay, I hope that everybody can see this all right.
We can.
You can hear me as well.
Icons at the bottom of your screen.
Sorry, what was that, David?
We can still see some of your icons at the bottom of your screen, but we can't see your slide.
Oh, weird. How's that?
Okay. Perfect. Perfect.
Okay, great. Thank you. All right. Well, good afternoon, everyone. Everyone who shares my longitude, and good morning or good evening to those of you who are tuning in from other time zones. My name is Donnell Gasparini, and I'm here today to walk through a murder mystery with you. This is all work that was conducted as part of my graduate studies at Laurentian University with this wonderful team of researchers here. And yeah, but without further ado, let's get started. So I'm starting today with a number, 53. Is it a big number? It depends on what we're talking about. If you were asking if 53 bites of chocolate cake was too much, I would say no, that sounds great. If you were asking if losing 53 hair elastics in a month is a lot, I would say no, that's pretty normal. But when talking about the number of turtles that can be lost from a population in a very short amount of time, 53 is a huge number, especially when considering that these are adult turtles. And so this is exactly what was found at the study site where all of this research took place. Is there were 53 carcasses of Blanding's turtles. And so this is our victim here, the Blanding's turtle. I'm sure that some of you are familiar, but Blanding's turtles are a very charismatic species. They have this bright yellow chin and throat. They have a little up notch in their mouth that makes them look like they are always smiling. And they're one of the 8 native turtle species that are here in Ontario. And so this species faces a lot of challenges here as it does elsewhere in its range. Different threats such as habitat loss, habitat degradation and fragmentation, poaching for the pet trade. So a lot of very human related threats that we are, I'm sure, all too familiar with across the various species that we study. And so yes, this is the species, and here in Ontario, they are a threatened species. So moving on to the scene of the crime. So this is the study site. It is a provincially significant fen. You can see the water is quite shallow, but it is all saturated. There are several tributaries that run through the wetland into a main water body at the base of the wetland. And this is, quite a beautiful habitat in all respects. It is a protected area up here in Ontario. And so because of this, the different causes of death that I looked at in this study are all natural causes. And for example, because we had all the carcasses, we knew that the turtles were not poached. So in this very beautiful and pristine habitat is exactly where those 53 dead Blanding's turtles were found. So yes, you're looking right here at the scene of the crime with the red tape up and everything. So before going any farther, a look at the carcasses, you can see here that the keratin, or the layer of the shell that contains the color pigments, had separated from the bone. Many of the small bones associated with the head, the feet, the tail of the animal were missing, and there was no soft tissue left, which as we move forward, you'll be able to see how this was a challenge for us. But first and foremost, it was a challenge because it really took a lot away in terms of what we could see and take as clues from the carcasses. We couldn't see any any evidence of disease. We couldn't see evidence of bodily harm or anything to the soft tissue. All that we had to go by were the skeletal remains. And so our suspects, as I mentioned earlier, we were looking at natural causes of death to these turtles. And so the three main areas that we were investigating are disease, failed overwintering, which was broken into 3 different subsections, and then predation in the active season. So I'm going to go through these one by one, and we're going to start with disease. So disease in reptiles is a very, especially wild reptiles, is an emerging field. There's more and more being learned every year in this area of science. And so there's a lot yet to learn here, but based on what we knew and knew at the time, we investigated ranavirus. And this is something that has been known to cause mortality in both frogs and in turtles. And this is based on studies that took place not too far from here in the Allender lab. And so ranavirus is a disease that can be passed between frogs and turtles and even fish. And so while a challenge for us was that we didn't have any turtle soft tissue to test, we did have many frogs present at the study area that we could take samples from and test them. And so our thinking here was that if ranavirus was present in the frogs, it's possible that it could have been harbored and could have led to the mortality of these turtles. On the other side, if ranavirus was not present in the frogs at the study site, our line of thinking was that it is unlikely that this was the cause of death. And ultimately, what we ended up finding was that none of our 30 samples that were taken from the amphibians at the study site were positive for ranavirus. So this suspect was ruled out. Moving on to failed overwintering. So as I mentioned, we're up here in the Great White North in Ontario, Canada. And so turtles do experience quite long and quite severe winter months here. And this is something that it affects their overall life history. I'm sure that we are all familiar with the slow life history pattern that turtles have, whereby they experience a lot of mortality early in life and then less as they age. But the payoff is that they're reproductive throughout their entire lifespan, which is quite long. And so up here where we have these long and harsh winters, turtles take longer to mature. And so that whole pattern is stretched out a little bit farther in that respect. It takes longer for them to become actively contributing participants in the population that they're each a part of. And so as we looked at overwintering, we looked at a few different things, one being predation during the winter season. So it's advantageous for turtles in the winter to hang out under the ice where the liquid water remains and where it gets very, very cold, but does not go below 0. And so while they're in this state, they are conserving energy and they're really not making very many movements at all. They're not capable of defending themselves. And so this makes them extra vulnerable to predators during this time. Even something like a snapping turtle cannot defend itself adequately in the wintertime if it is found by hungry predators. And so when considering predators, we looked, one kind of method that we undertook was to look at tracks in the snow. So you can see here the tracks of a few different species that are common here, as well as a tape measure we were using to measure gait and track length and width. And then we also deployed motion activated wildlife cameras. So you can see the camera here strapped to a tree, and these were used to capture images of any wildlife that were passing through the study site during the winter at key locations. And so our goal here was to capture a glimpse of what predators were moving through the landscape at this time of year. And we did find some predators, such as these 3 coyotes that are going through along the very same track in the wintertime. So these were images that were all found in February, just put together into a little GIF here. So yeah, we found predators, but what we didn't find in the wintertime was evidence that predators were seeking out turtles. We had no turtles, for example, dug up or no predators breaking through the ice to access the turtles. And so our next line of inquiry was looking at freezing during the winter season. So as I mentioned, it's really advantageous for turtles to stay in an area during the winter that remains liquid water and that gets very, very cold, but the turtles cannot be in an area where the water completely freezes around them as ice, or where it gets to sub-zero degrees Celsius temperatures. And so what we did in the wintertime is we had a subset of remaining turtles that were living at the study site that were like naturally occurring there, part of the original population. So this is a transmitter over here so that we could follow them using radio telemetry. So we followed them throughout all seasons to collect different clues. And at this time of year, we also attached an eye button. So that's what's under this layer of epoxy. So it's a small disc that allowed us to get a temperature profile for the turtles while they were in their overwintering stage. And so it recorded temperature through all of the winter months. And then to complement that, we also had bricks that we put eye buttons onto, and we deployed these bricks in areas of the wetland where turtles were not known to be overwintering. And we did put some in areas where the carcasses were found. And so we were looking to compare the temperatures, of the turtles in the spaces that they were overwintering, and then to use these bricks as a way to look at that same profile in other areas of the wetland. And you can see here what we found over 2 different years of study, so 2 winters. There's greater variability for the haphazard stations, which are the winter stations, particularly in the sub-0 degrees Celsius or sub-32 degree Fahrenheit range. And so the bricks did experience temperatures that would have been too cold for the turtles to withstand, whereas the turtles followed exactly what we expected, but to see it play out in real life through these analyses was very exciting for me. So we saw that the lowest turtle temperature reached exactly 0 degrees Celsius. Whereas the lowest brick or the lowest haphazard temperature was negative 5.4 degrees Celsius or 22.28 degrees Fahrenheit. And so when analyzing this, we used general linear models where we had several fixed effects, including the station type, so whether it was a turtle or a brick haphazard station, mortality or non-mortality site, and year. And then ID was introduced as a random effect to account for repeated measures. And what we found through these analyses were that the difference between were, oops, sorry, I've lost my screen here. I hope I'm back. So we did find a difference between the turtle sites where they were overwintering and where the haphazard stations were. So this provided strong support that the turtles, we didn't really have doubts, but just had to check it out. They didn't, they knew what they were doing and they were overwintering properly and successfully surviving winters. And so moving on to acidosis, to look at this, we had to use a handheld auger to make a hole in the ice and then deploy our equipment through that hole to reach the liquid water beneath. And then we recorded the dissolved oxygen content in that water in milligrams per liter. And so you can see here between the months of February and March, the dissolved oxygen content at our study site was quite high. There was consistently oxygen content in the water, and looking at a comparison site elsewhere here in Ontario where this same species is known to be present and to overwinter successfully, you can see that the oxygen levels at the study site were actually a lot higher than those at the comparison site. And so through this data, we were able to see, first of all, that there was no difference, no statistical difference between the sites where we were looking where turtles were overwintering and then the dissolved oxygen at sites where turtles were not overwintering. There was no statistical difference there. And then also, if the turtles are able to survive in conditions with such low dissolved oxygen as what's seen at our comparison site, then surely this can't be a limiting factor here at our main study site. And so thinking about all of those three lines of thought, it's clear based on the data that failed overwintering was not the problem. So moving on to predation in the active season, our final suspect. What we looked at for this, again, there were a few different ways that we evaluated this. One of them being injuries, both old and new. So you can see on these blanding turtles here that we've got some injuries in the red circles, some chips on the shell, some marks and smaller marks here. And then this turtle here represents a turtle that actually got some new injuries during the study. So the spots that are all circled in red there show areas where the keratin was damaged on the shell, and also where some of the epoxy was damaged on the transmitter. And it really seemed, it's a little difficult to tell from the photo, but when we had this turtle in hand, it looked pretty clear that something had captured the turtle and had taken an interest in the transmitter and kind of like gnawed on the space around it. Maybe that's what was easiest to fit into their mouth. But anyways, that's how how the turtle presented. But luckily this turtle did manage to escape, and she was let go at the end of the study. We took her transmitter off, and I do hope that she is still surviving and doing well in this habitat. We also used a bit of a novel approach, and we used a Blandings turtle decoy as a means of enticing and luring in potential predators. So hopefully you can tell here which Blandings turtle is the decoy and which is the real deal. But I hope that you can also appreciate that to a predator, this Blandings turtle decoy may be quite convincing. And especially when it is doused with urine and other water from a captive Blandings turtle tank, which was done to further appeal to the senses of predators. And so this decoy was paired with a camera. So we've got our camera here on a little post in the wetland, and then the turtle decoy circled there. And the decoy was strapped down to the bottom of the wetland using just some wire coated in plastic. And this was so that if a predator came and tried to actually take the decoy, it would not be able to do so in such a quick and swift movement so that the camera couldn't capture it. We wanted to create a condition where the predator would have to stay for at least several moments so that the camera could take good photos that we would be able to use for identification purposes. However, I don't know if others agree with this and have experienced similar things, but Murphy's Law is, it's well known and it's known to be true, but I find it's known to be especially true during fieldwork. And so when our decoy was removed from its spot and torn to bits, the camera did not capture anything. And so I'm sure that you can appreciate my frustration to see what I saw afterwards, which is a decoy just like this. Well, actually this decoy exactly, torn up and left many meters away from where it was originally stationed. And then to plug in that SD card from the camera and have nothing. That was excellent. That was a great day. And so you can see here the decoy, I've put in the red circle some pieces of the foam that were removed from the decoy. And so something that struck myself and my team as very interesting was that this decoy seemed to be meticulously torn and not randomly torn. And so you can see that a little further in this photo here. So this is what would have been the head of the turtle. You can see a little bit of that yellow here. And the whole decoy was made of the same material. It's like a foam, kind of like a Nerf ball. And it was painted. And interestingly, you can see if we go back here, that none of the limbs are still on the turtle decoy, that its tail is gone. And then looking again here, that its head is also gone. And so this is very interesting because it follows the same pattern that many predators will use when pursuing and consuming turtles, because this is where the protein and the fat content is in the body of the turtle. And so, yes, this was something that was very interesting. And And despite not having photos of the predator, it certainly lends support to this line of inquiry. Moving on here, so we did capture some predators or potential predators using the motion activated wildlife cameras. So this is some images of a family of otters that were in the area. We also got evidence of predators such as raccoons, the coyotes, which you saw earlier. We had some in the summertime, but not as many as what we saw in the winter. And so there certainly are predators present in this study area throughout the entire year, which certainly is not unique to this area. Predators, as well as their prey, interact with them. It's what you need to keep them going. And so confirming which predators were present was helpful, but couldn't exactly help us to definitively say too much. And so as this story progressed and as we spoke with locals in the area and got the story known, I guess, by the people who are familiar with the region, we did have people coming forward with some information of their own to share, which was really, really great and really interesting for us. So on the left-hand side here, we have a photograph of a dead turtle at our study site. You can see that it still has 2 legs, and you can see its little tail poking out at the posterior end of its shell as well. So it's plastron up, so it's upside down where it's sitting. And the photographer described the head as being gnawed off. Cannot see that in the photo, but at the time of taking the photo, the photographer did not know what significance the photo would later have. And in addition to this account, which came with the photo, we had several other park visitors come forward and report similar sightings. And so this was something that helped us to bridge that gap a little bit that I mentioned earlier, where the soft tissue would have been able to lend some clues to our case. So this was very valuable information, and we were very lucky to have these individuals step forward. And then something else that got thrown into the mix here and that was very important to consider is the habitat itself. And so through some of the photos that you've seen today, you may have noticed or you may have thought to yourself that this is an unusually shallow habitat for Blanding's turtles. And that is certainly true. There were times where chest waders were needed to avoid soakers, but at other times of year, my team and I were able to move through the landscape with rubber boots as long as we were careful. And looking at the historic data for the area, we can see here that this area circled in red at the very end of this graph here, this is the time in which the mortality happened. So the mortality occurred in 2012, and that was also a record low water year for the adjacent lake, which is a very significant body of water. And so considering that, we can look at some of the photos of the site, and we can see here this photo that was taken in 2012. We've got some sedges and we've got a lot of very dry area. I hope you can see, like right here, there's a little glimmer here, and that's water that's part of one of the tributaries that runs through the habitat. Comparing that with a photo that I took while out at the site in 2015, the same area, the same site, but quite a different appearance to it. So you can see in 2015, the landscape was saturated. The plants, it was clearly a different time of year. We've got very brown plants compared to very green plants. But you can just really tell that the level of the water does fluctuate, and that in 2012, to call it a wetland probably would have made some people laugh. Whereas in 2015, that idea would not be debatable. And so thinking about this and thinking about what we saw as in terms of predation in the park, tying these things together, looking into the literature, it became quite clear that something that is not too uncommon is that predators who rely on animals that live in wetlands or in aquatic habitats can shift their prey source if the habitat conditions change. And there's actually several published papers as well as other in the gray literature that suggest that otters are known to do this. They're known actually for a few different things. They're very playful and charismatic. They're very smart. They will often kill more than what they fully consume. And exactly as I was just saying, if the conditions of the area change, otters in other places, both in Canada and elsewhere, have been documented to shift their prey source from other animals to turtles and to consume the turtles in exactly what we've seen here through the account from the photographer, through looking at that decoy, and that's consuming the head and the limbs and then leaving the rest of the body to decompose. And so it looks, based on what we saw, and we knew that this would be challenging from the beginning to pin down an exact cause, but based on everything that we examined, this is the strongest line of evidence to show what caused the mortality event in this particular case. And so thinking about mass mortality events, the frequency of these events is predicted to increase. There is very little known about these events and about their long-term consequences, especially for animals that rely on long-term persistence, such as turtles. So it's with them becoming more and more predicted to be more and more commonly occurring, it is important to become aware of the consequences, aware of them as a threat to species at risk, and to identify worthwhile conservation initiatives. And with that, I would like to say thank you to everyone, funding bodies, to my field technician team, to my academic team, to my personal team, everybody who helped me and made this research possible. It was a phenomenal project to work on. I will always think of it very fondly, despite the grim topic. And so this brings me to the end, but maybe not quite. So I'm going to throw two more numbers at you. 55 and 41. These are not the numbers of the loonies or the toonies in my pocket, though I wish that they were. These are actually numbers of turtles, more dead turtles that I've personally been involved with. And so 55 Blandings turtles and 41 painted turtles were found in a different wetland in a different area of Ontario in this current field season. And so it felt quite a lot like deja vu, finding a lot of carcasses, as you can see here, partially decomposed. And yeah, certainly a very grim sight, not something to be very excited about when out in the field. And so this is just a very quick figure to show historic mortality at this site. So you can see for both species, mortality does occur, but not in surprisingly high numbers, until we get to this year, where we had an overwhelmingly high mortality for the painted turtles. These were almost exclusively female adults, excuse me, and for the Blandings turtles, juveniles that are part of a conservation initiative in the area. And so, again, very, very scary. I come back to this slide of the significance, and I just want to really stress that as I've shared these stories, the first over the past several years, and now the second more recently, what I hear are accounts from others who have seen something similar or know of something similar that wasn't documented. And I really just want to stress that the contributions of this information to the literature or to these bodies of knowledge that we all refer to when seeking guidance, it's so incredibly important to get these out there and to be able to understand these better. Mass mortality events are, again, predicted to increase, and understanding their long-term consequences and how we can adequately address them is super helpful. And it's something that now more than once I've been trying to figure out and have been at a bit of a loss as far as what has happened in other cases. And so I once again want to say thank you to everyone who is involved in this second mortality event research. It's certainly been a collaborative event to collect all of the data, and we are continuing to monitor the populations and to analyze what we're able to collect. And so with that, I would like to say my final farewell. Thank you everyone for your time today. Thank you to the other presenters, to the organizers of the conference, to those tuning in to watch. I think something that we are all missing this year is the great community that is the herpetological community. And I'm just so grateful that I was able to participate in this virtual conference this year. Yeah, I'm happy to take any questions that you may have.
There are 4 questions, and you can find those in the chat, or I can read them off to you.
Perfect. Okay, I've just got the chat open here. So question number 1, did you track the turtles to know exactly where they were overwintering? Yes, so we tracked the turtles to gather key pieces of information, and this was exactly one of them. We tracked them and we kept the transmitters on during the winter so that as we were out at the site, we could confirm their location at each visit and know exactly where they were spending the winter. Question number 2, how do you know that your dissolved oxygen measurements aren't affected by the auger drilling and equipment deployment? Okay, that's a good question. I could certainly see how the auger and the equipment deployment could stir the water up and could introduce increased amounts of oxygen to the system. What we were doing is we were doing our best to not disturb the water. Obviously, initially, that's impossible for anyone who's used an auger. I'm sure you can picture that. But letting the water settle, and the water does move slightly through the wetland, so letting it settle and hopefully return closer to the regular resting amounts. But yeah, thank you for that question. That's definitely something important to consider. Number 3, if it was failed overwintering, would you expect to find the carcasses on the surface of land? Okay, yes, so good point. So most of the carcasses were found on land. And it's not that we would expect them to be found on land if it were overwintering, but it's more that we knew from the state of the carcasses that time had passed since the turtles had died. And so we thought that they may have actually died in the wintertime and then been brought to the surface by a predator when they were accessible again in the springtime. Question number 4, did you try more than once with the decoy? We did. So we had multiple decoys set out at the study site, and the one that I've shown in the presentation is the only one that experienced its own mortality. And the other decoy that we had in the habitat was in a different area of the habitat, and it was investigated by animals like deer, but it was not torn to bits like the one that I've shown here was. Question number 5, what is the otter trapping harvest situation in Ontario? So we do have an open season for otters up here in Ontario, typically in the fall time. So I believe that it starts in October and goes until some point in January, so fall to early winter. And outside of that season, trapping is not permitted. And the last question, a couple of days ago, we heard a talk about corvid predation. Is it possible that you have a combination of corvid predation and scavenging by other animals? It is possible. We did keep, I didn't have photos in this presentation of them, but we did have ravens check out some of the decoys that we had. And we have spoken to other researchers who have observed predation by corvids. And something that was unique in their findings and different when comparing their findings to those of this study is that what they were seeing is that they were digging in through the soft tissue in the leg sockets of the turtle and pulling out insides, particularly eggs, but also like organs and other soft tissues, whereas they weren't really targeting like the head area. But anyways, it's certainly something to consider. And while we've done our best and collected all the evidence that we were able to after the fact, it certainly is something that does seem like it was a multi-factor issue, and that's what ultimately caused the mortality here. All right, thank you all so very much. I appreciate your time. I appreciate these great questions. And I always love an opportunity to share this story. So thank you for that. And I look forward to the rest of the talks during this conference.
Thank you, Donnell. That was great, great stuff. And thank you to all of today's presenters and everyone who joined us this week. Be sure to check out poster session 2, which went live today at turtlesurvival.org, and join us next week, same place at 11 a.m. Eastern Time. And we will have week 6, third one until the end. So we have 3 left. Don't miss them. We will see you then. Thank you.